visible light communications. My name is Luís Neiro Alves. My talk today will be about visible light communications-based indoor localization with machine learning. So advancing for the next slide. This slide will shows the contents of my presentation. So I will focus on the introduction and motivation aspects for indoor localization with visible light communications, state of the art, some indications about the state of the art in this field are outlined here. Then I will talk about system modeling, how the system is composed, and the key components that we need to take into consideration. And then I will present some work examples that we are taking at my institution, Instituto de Telecomunicações in Portugal. Then I will conclude with the final remarks. I will not display my image in all the slides in order to not disturb the content. So moving to the next slide. Why we need for positioning. Positioning is becoming a major need in current societies, most often. So we find this in huge infrastructures like shopping malls, airports, train stations, to mention a few, with lots of applications that demand accurate position estimation of the users in the environment. Of course, we have seen also in global navigation systems by satellite, the GPS. The market for GPS applications is also an increasing market with a very rewarding revenue worldwide. However, if we think about GPS is not a good solution for indoor environments. For indoor environments, there have been tried different solutions based on ultrasounds, RFIDs, radio waves, ultra-wideband, Bluetooth, Zigbee, amongst others. But all these have in consideration the use of radio, or in the case of ultrasound, sounds, which are prone to some environmental constraints. For instance, radio waves are very prone to multipath reflections, and as an end result, the positioning systems based on these radio waves will degrade the performance and are not able to deliver very accurate centimeter range estimates. Ultrasounds, on the other hand, are also prone to temperature variations in the environment, which make them not suitable for indoor localization. For indoor localization, the visible light communications and most relevant visible light positioning is becoming one of the promised applications in the market. So in VLP systems, the location of the receiver is estimated based on light access points that we have present in all our infrastructures. So the infrastructure for illumination is used with the dual purpose of illumination and convey information for positioning purposes. This will imply high security, usability, privacy, safety, and trustability. So it's a very promising technique. In terms of applications, visible light positioning applications are becoming to appear in the market and in the research. And interesting application scenarios such as mobile robots in hospitals, smart manufacturing, tracking and localization in indoor spaces like shopping malls, train stations, or even the indoor communications combined with positioning for also large infrastructures like train stations and airports. Indoor positioning market is already generating revenues as 2020 4 billion US dollars and increasing. So it's the right moment to address the introduction of new technologies in this important market. Since the 70s, GPS has evolved. And from late 90s, technology involving positioning systems began to evolve after mobile network service entered the prosperous area. The use of VLP is one potential approach in this range of techniques. In terms of state of the art, we have made a thorough research on the state of the art of visible light positioning techniques with some students at my institution. What we found out is that the number of papers and contributions to the research is increasing, and it has been increasing since 2008 when the technique was first introduced, now reaching to a state of 350 papers per year, around that, and increasing. Among the research fields, most of the papers focus on traditional positioning approaches based on receiver signal strength, time of arrival, angle of arrival, time difference of arrival, or phase difference of arrival, and also fingerprinting and proximity based positioning. Other methods, including sensor fusion or image processing, or even the use of machine learning techniques such as artificial neural networks, appear next. We also have a lot of contributions focusing on the simultaneous positioning and orientation of the devices. In terms of system modeling, the system modeling for visible light positioning systems entails a room, of course, a room equipped with a set of luminaires. Luminaires act as position beacons, so the transmitters in the system. The receivers can be any device equipped with photodetectors or image sensors. Could be a portable device or a fixed device. And then estimating the positioning error can be done using multiple algorithms. For instance, with traditional algorithms, we resort to receiver signal strength, angle of arrival, or time difference of arrival, amongst others. We can also combine these kind of traditional algorithms with machine learned based algorithms. Machine learned based algorithms include classification. Classification is regression is mostly devoted for methods involving receiver signal strength and angle of arrival or time difference of arrival. In terms of the system modeling, the information is combined using visible light communication. So this slide shows the concept of a visible light communication system involving the luminaires. The luminaires are backed with some lamp driver that is modulated with information. The information for positioning consists on the position of the luminaires in the room. Each luminaire then transmits a set of information, an ID, which is independent and orthogonal amongst each other, in order for the receiver to detect some features about each transmitter. These features that are estimated on the receiver may include receiver signal strength, as we talked before, time difference of arrival, or even angle of arrival, if the system or the receiver has the ability to discriminate directions. The receiver could be any device inside the room, so portable computers, laptops, smartphones, or any autonomous agent equipped with imaging devices or photo detectors. The light sources themselves, we have the requirement for the light sources to be based on LEDs. Based on LEDs, this is because LEDs offer the possibility to switch on and off at fast speeds. Of course, depending on the technology used for the LED, we may have different data rates available. Mostly for positioning, we are speaking of LEDs that are used for illumination purposes, so white power LEDs with moderate data rates in the range of tens of megabits per second. In terms of photo detectors, positioning estimation is based on the presence of pin photodiode or avalanche photodiode. It's the two types of photo sensors that we have. So pin photodiodes are low cost, have large area, and limited sensitivity. If we aim for higher sensitivity and smaller area, we should use APDs with higher reverse bias, so it may represent a higher cost in the system. One issue with single element photo detectors is that single element detectors cannot separate multiple sources directly. So if we have multiple sources within the room transmitting information or positioning information for the receiver, all of them will be combined in the same photo detector. So the signal will consist of different signals from each transmitter. Another type of promising device for positioning systems is the image sensor. Image sensors, which can be CCD or CMOS arrays. These have the ability to separate sources spatially, so present a superior performance in terms of what we can do for positioning with a single device. The channel is, of course, the optical channel. So optical radiation is propagated from the transmitting source to the receiver, and it can undergo a set of reflections in the walls and furniture inside the room. So this becomes a critical parameter in the estimation of the positioning accuracy of the system. The positioning accuracy of the system will depend strongly on the availability of line of sight. So if we have line of sight, we can estimate directly what is the receiver signal strength or the angle of arrival for a given source. If we rely also on the reflections that occur in the room, this information is perturbed. So we have to take into consideration that the channel is not perfect. The channel involves reflections, and as such, the algorithms that are used to estimate the position must handle the presence of reflections. So in terms, just to give you an idea of the channel, for an empty room, the channel can include line of sight. So we can directly compute the line of sight using the equations I shown in the slide before. And we can also compute the known line of sight. The computation of the known line of sight is a complex task. Usually it is required to have access to specialized software like Optics Studio from Zemax. And the combined result, the combined line of sight and non-line of sight contribution is what we detect with the photo detectors inside the room. So as this picture shows, it could be quite different from the line of sight only component. So in terms of system modeling, again, we have the positioning algorithms. The positioning algorithms could are usually adapted to the kind of technique we use. For instance, we use circular lateration if we are relying on receiver signal strength or time difference of arrival. We can resort to angulation. So if we have a method based on angle of arrival, or even hyperbolic lateration, again, using time difference of arrival and receiver signal strength. For scene analysis, usually what we try to find is the closest match to a set of fingerprints already stored in the receiver. Methods that become conventional in the estimation are the linear least squares. Most of these problems can be formulated in the form of linear least squares, especially when speaking about receiver signal strength, or nonlinear least squares using some algorithm to find the minimization of the cost function, which usually is a cost function involving the real position and the estimate position, the comparison between the estimate position and the real position with the received information. We have performed some works in our group. The first approach that we used relies on polynomial regression and nonlinear least squares. So it's a combination of the traditional approach using nonlinear least squares model to approximate the positioning inside the room, but using a polynomial model to infer the channel to model the channel. The idea of the polynomial regression is to modulate to develop a model for the power to distance estimation with multipath reflections. So we performed a set of simulations having in mind different constraints, mostly having in mind the uniformity of the solution. Lighting uniformity is important for the illumination of the room, so having an idea of what is the impact of the positioning system in the uniformity of the lighting is important. So the distance between transmitters or distance between luminaires is optimized in terms of the half power angle of the source and also the uniformity constraints. Then we simulate the channel. So the channel is composed of line of sight and non-line of sight information. And the importance for the study was to find what were the uncertainties in position when we take the placement of the luminaires in the room as uncertain. So here in this slide, I show the traditional distance to power relation using line of sight only model, which will not work for a system with a multipath channel. So for a multipath channel, we resort to a polynomial. Here we find a polynomial fitting and the CDF for the error using the nonlinear least squares with the conventional line of sight model, the error is, as you see, high. We can reduce the estimation error if we use the polynomial regression effectively. Basically, what we found out, having with this study, is that the uncertainty in the position of the transmitters has impact on the estimation error for the positioning system. And basically, the error will increase with the precision we have placing the luminaires on the ceiling. Also, we found out that the orientation of the luminaires has higher importance in the error than the position of the luminaire itself. So it's the major finding. This has been reported in a paper on sensors in April 21. Another study we did was has to do with the position estimation with tilted LEDs. So here the idea was to tilt the LEDs on the ceiling towards a focal point in the room, and show that with this tilting effect we can effectively improve the accuracy of the estimation error. Of the estimation of the positioning. Figure shows this graph shows the error, as you can see, without any tilt in blue, and with tilting for two scenarios, so different tilting angles. And as we can see, the different tilting angles imply different performance, but in all these two cases reported, what we can see is that the performance is better. This has also been published in a journal in Sensors in January 21, as you find out in the slide. Another important effect is the blockage effects. The blocking and shadowing in indoor positioning can occur, for instance, because you have furniture or you have movable objects inside the room, users, which perturb the transmission between the transmitting beacons and the receiver. As such, you should expect errors in the positioning. We have made a short contribution for PMRC in this year, which studies the impact of a moving person inside the room. What we see is that the error increases dramatically when you have the blocking effect of people moving inside the room. This is an important finding, and of course it's a good direction for further research, as we need to develop new methods and new models able to take into consideration the presence of moving people inside the room, and above all, improve the position estimation even with this in hand. Another study, and this one using support vector machines, so very widespread technique in machine learning, was to improve the performance using support vector machine and polynomial regression as a whole. So what we set up was the room, divided the room into different areas, and find a polynomial model for each of these areas. Then with the support vector machine, we do the classification in order to discover which points belong to which area inside the room, and show with this that we can improve the accuracy. We did this study for an empty room and also for a furnished room, and we showed that it's possible to improve the accuracy of the positioning estimation using this approach. This is about the method, and here I can show you the results. So you have the CDF of the error for different scenarios, so nonlinear least squares with polynomial for the entire room, and then using the best fit scenario for different polynomial models, which we can show that increasing the number of polynomials or the areas inside the room, we can in this way improve the accuracy of the system. Also, for the system with the furnished room, we show that it's possible to improve almost 200% in relation to a single polynomial for the entire room. And finally, I just want you to brief you on this. We have also been investigating the usage of artificial neural networks as a way to estimate the position for a positioning system based on the photo detectors. So in the setup, we have N transmitters. These N transmitters traduced into N received powers on the receiver side. These received powers are converted to distances using a polynomial model. So the polynomial model takes into consideration the conversion from power to distance. And then the inputs of the network are these computed distances for each photodetector. The network was optimized, and we took into consideration different optimization steps. So basically, we investigated which which training method is best fitted for the application. Our finding is that Bayesian regularization was the best method that shows superior performance. We also optimized the number of neurons and for a two-layer network. We investigated also the effect of the training epochs on the method, on the training, showing that we can improve having a large training number of epochs. And the final result shows that the achieved performance can be better than using nonlinear least squares, which we took into consideration on this study as a comparison. So advancing for the final remarks, we have discussed the visible light positioning as a suitable technology able to achieve centimeter range accuracies. This has been shown by simulations, but the first results, practical results, are also showing that centimeter range accuracies are possible. Numerous methods can be employed to estimate position of the receiver, merging traditional approaches with machine learning. And also, machine learning algorithms promote interesting solutions for channel-induced effects. Multipath reflections is one thing that we can address with different machine learning algorithms. Also, blockage and moving obstacles, and the presence of furniture inside the environment. And this concludes my presentation today. So thank you for your attention, and I will be available for questions and answers now.
Okay. Thank you very much, Professor Luis Nero, for the nice presentation and interesting presentation. So we have some minutes for a couple of questions.
Okay. Hello, Pablo.
Yes, Professor Alexander.
Yes, good morning to everyone. Yes, I'm not able to find here's the button to raise the hand, so that's why I'm asking always
It's down in reactions. It says reactions.
Yes.
Reactions.
Reactions.
You click,
Okay. Okay.
and then you have the hand.
Yeah. So I'm late here. Sorry.
No, it's okay. It's okay. No problem.
Okay.
So you want to ask
all
a
right.
question?
Thank you, Paulo.
Okay.
First of all, hello, Luis. So it's a pleasure
Hello.
to see you again. It's been already 2 years that we have met there in Aveiro, eh?
Yes.
It's been a long time already. Yeah, I hope you are well. So yeah, it's a very nice presentation. Thank you. I just have one question about the what would be the impact of having on the accuracy of having more or less light sources on your room concerning the positioning systems. In how much would that improve the accuracy, or do you have any data or information on
Yes,
that?
one of I don't know if I can share the presentation slides.
Yeah.
We'll try.
Maybe you have to put him as co-host.
No, he can share or not.
Are you sure?
Okay.
Let's try directly, please.
Yes.
Yes.
Try directly.
Diego is the host.
Okay.
Yeah.
Can you
Okay,
see
very
it?
good. Yes.
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 So let's go here to one slide. This is actually one of our initial studies, was about the accuracy of the position estimation, taking into consideration the uncertainty that we have when we are placing the luminaires in the ceiling. And we did this study with a range of different numbers of transmitters. So as you can see here in these curves, for the uncertainty related to the angular uncertainty and the positioning uncertainty, we repeated this for 4, 9, and 16 transmitters. Of course, increasing the numbers of transmitters as a global trend of reducing the position estimation error. But of course, it will imply a larger cost in terms of installation.
Okay. Yeah. Okay. Thank you. Yeah. Good. Thanks a lot. Yeah.
Okay. Thank you very much, Professor Luis. Any other question? We still have time, 5 minutes.
Cristobal is raising the hand.
Okay, Cristobal. Sorry.
Thank you very much. You can hear me?
Yes.
Yeah, thank you. Thanks all. Thank you, Luis, for your presentation. It's very clarifying for me. And I'm working on the use of PDs also. And I have one question, because you consider the direction of the normal of PD, of his orientation, it's parallel of the or 90 degrees of the floor. So my question is, what do you think will happen when you consider the uncertainty of the same that you did with the transmitter, but with the PD of the receiver? Because it will be affected.
Of course, but that's the traditional approach you have when you are entering into visible light positioning systems, which is to attribute the uncertainty always to the receiver. Okay, so having a tilted receiver, of course, it will have impact on the position estimation error. We didn't address that. We were considering only on this study in particular the uncertainty in terms of the transmitter side. But in a different study, we explored the usage, this one I'm showing, we explored the usage of tilting on the transmitters in order to improve, which is actually contradictory to what is normal in the literature. So when you are setting up a lighting installation, what you do is having all the luminaires pointing down, right?
Right.
And this will give you the better uniformity in terms of lighting the installation. But what we saw is that tilting the LEDs to a focal point, which can be anywhere inside the room, improves the accuracy of the system on that particular site.
Yeah.
So you have an area-dependent method of localizing objects inside the room. We didn't investigate this with tilted photodiodes, so the receiver tilted. So I'm not
Yeah,
sure if it will have impact, but of course it will have some.
Yeah, because your curve or your fitting approximation of the distance, it will be worst when you consider a tilde PD.
Yeah, you're right.
And that is not true, actually.
Yeah.
It's very difficult to approximate that function.
Yes, it is. We have been doing this for, as you say, for photo detectors always pointing up 90 degrees with the floor plane and looking to aspects related to the multipath channel.
Okay.
But it's an interesting direction for research.
Yeah. Because I'm working on this direction, and it's very difficult to approximate the just one function, because in fact it's not linear, and in fact it's not that function, because if you oriented a different position, it's hard.
Actually, one work that we are pursuing right now, but not using photodiodes, using image sensors, is addressing exactly that. So if you have the tilted on the receiver side, so the CMOS array is tilted, what impact you have on the position estimation, and we are seeing some strange things. So not sure yet what we have, so we are exploring, and hopefully in the next few months there will be some paper.
Thank you. I will expect your publication.
Okay. Thank you.
Thank you very much.
Okay, thank you very much, Professor Luis Nero, again, for such a nice presentation. In view of the time.
My pleasure.
Thank you very much. In view of the time, I think we should move. Maybe Fabian, you can share the screen for the next presentation, please.
Okay.
Thank you. Okay, so now we are going to listen to the presentation of the paper Support Vector Machine and Artificial Neural Network Classification using GLCM and Hawk features for COVID-19 and pneumonia detection from chest X-rays. So the authors are Carlos Fernandez, Ismael Soto, David Zavala, Wilson Alavia, Veronica Garcia. So, okay, Fabian, you can run the presentation.
Hi everyone. Today I'm going to talk about a work that we realized with Ismael Soto, David Zavala Blanco, Wilson Avila, and Veronica Garcia. The title of this work is SVM and ANN classification using GLCM and Hawk features for COVID-19 and pneumonia detection for chest X-rays. This work was realized on the Center for Multidisciplinary Research in Telecommunication Technologies of the Department of Electrical Engineering, our University of Santiago of Chile. So, here we have the table of contents. We are going to start with a motivation for some context of this work, the objectives of this work in particular. Next to it, the methodology with some process that we apply to resolve the problem that we are proposing, and finally the results with the conclusions and the future works that we proposed. So, at first, the motivation. So we know that all of us are living on a pandemic world right now. So we have to find ways to generate a fast recognition of this of this of COVID-19. So at the right figure, we can see some information about the PCR tests. And we know that is the most popular way to have a, a test of the COVID-19, a diagnosis of the COVID-19, but we are finding another ways to get information. So this is basically the first motivation of this work. So the objectives that we are proposing are to contribute with an alternative design to supporting automatic diagnosis of COVID-19 positive cases, particularly addressing the design of an automatic lung design DSOS classification software. So to present the methodology of the automatic classification of lung DSOS through CHET X-rays, addressing aspects of the dataset, features extraction, and the use of different classifiers with the definition of the most important parameters. So we are going to start with the methodology. At first, we can see here on the system diagram at the left the input of the system, that in this case are the patient on an X-ray. So we got an X-ray from the chest in this case, and we can see that we are running an algorithm that get some of these patches. So we analyze a patch on this image, on this row. So we are going to analyze all of them, and when we obtain these patches, we are going to process it through an AI. And in this case, we are going to get some feature extraction and classification. So we are going to get some features and we are going to classify them to obtain some results of diagnostics like COVID-19 or pneumonia, or in the case that they are healthy. This is only a suggest, not a definitive diagnostic. So right here we have 3 photos. In these X-ray photographs, we can see different situations. At the left we have the COVID-19 case, at the right a pneumonia case, and in the center we have a healthy person without these situations. So right here we can see the difference. I think there are some difference between COVID and pneumonia that are we can clearly see. I think a doctor is the doctors has some type of analysis that they have to realize to some characteristics. In this case, we are going to try. We want to obtain this characteristic through our algorithm. So what we do has these patches that we are talking about. In this case, there are 2,100 patches, and the dimension of these patches are 64 per 64. And basically, these patches are going to be analyzed through 2 methods. In this case, HLCM methods that analyze contrast, dissimilarity, homogeneity, angular second moment, and energy and correlation. All of these features are setting on a dataset next to the HOG results of this analysis, and all these analyses are going to training a model. So what we are doing right here, we have 2 examples of a patch analysis through CXR and the HOG feature of this model. So The classifiers in this case that we train are the artificial neural network, multi-layer perceptron (MLP), and the support vector machine (SVM). So in the two cases, in this case we have the SVM graph showing the hyperplane separating the samples from the classes. We can see clearly the three classes, and we have the cross validation of this model. We train the model and we find that the cross validation do correct work. We have the same precision of the model in the different cases. So basically the result of this model, we can see right here the SVM learning curves. We can see that we obtain good efficiency with good precision in SVM and ANN learning curves. In this case, in the left case, we have 87 features and polynomial kernel, and we obtain an accuracy of 99.73%. This is a high accuracy model. The time of execution of this model are nearly for 4 seconds. In the second cases, we have a lot of features. We have 121 features. We can see some parameters that we input on our function, and we can see the accuracy that we got are 93.43%. The time of execution are 25 seconds approx. So right here we have the confusion matrix of the two models. We can see that they are working great for the detection and classification. And finally, our conclusions are that the methodology proposed to the automatic classification of lung diseases such as COVID-19 and pneumonia has been described and validated successfully. Relief results are seen for both SVM and KNN signs the cross-validation curves that with data from testing generate better for the new data. Using 6,300 patches of CXR through the extraction of GLCM and HOG features, and then using machine learning techniques with classifiers such as SVM and ANN, perform cross-validation. A maximum accuracy of 93.73% was obtained for the SVM. Therefore, this classifier can be implemented for CXR from other patents due to this good generation capability. So the future works that we propose are the develop of an algorithm that extracts patches in a way that eliminates the RIP areas of X-rays image of patient, and those experiment if its higher accuracy can be obtained. To validate a prototype of the diagnostic system with a team of radiologists performing field tests, and to design the graphic interface with remote connection to a centralized server for end users of the system. So these are going to be all of our presentation. Thank you for the attention. Right here are the reference of the work. And thanks.
Okay, thank you very much for the presentation, Carlos. We still have some minutes for questions. So is there any question in the audience? Hussein. Okay.
Yeah, it's
You can
Hussein.
ask.
You can hear me, right?
Yes.
Yes.
Yeah. I think this is absolutely something very good for all of us human beings, especially during the crisis that we are going through. It can save lives. I thank you personally very much for this. However, I do feel that, as much as there is accuracy to it, it can be quite challenging to obtain those patterns that will activate your automatic detection of those chest patterns of someone has COVID, because I think sometimes a challenge would be is that it can overlap with other lung diseases, right? I mean, this could be a solution also. It can expand the system. It can tell you what other diseases, contagious diseases that you have. This is my first question. Do you think it overlaps with other diseases? Because we are still during COVID. And this brings up my second question, which is also similar. We are still within this crisis. A lot of people, they claim that it's far from over. Are these studies, are these patterns that we have, the chest patterns of someone who has COVID or pneumonia, are they based on the early diagnosis of COVID during the start of the pandemic, or is it still ongoing? Because to my understanding, the new variants, yes, they have all these common symptoms, but they might have different patterns. So how are you planning to deal with this? Those are my two questions. Thank you very much again.
Okay.
Paulo, can I respond? Because Carlos couldn't attend to this meeting.
Oh, okay.
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 We'll answer.
Yes. So, Hussein, thank you very much for your question. We are doing this prototype. Yes. Science, we are working in a project with people from biology department, and they are doing a DNA recognition, and we're okay with them. Yes, because you see, with the pandemic, the government give to our university a very expensive equipment, you see, to perform the PCR. Yes, and we have one of the centers, more important center in Santiago, you see, to do the PCR. Yes, and so we are trying to accelerate that process. And the paper that we are presenting at the conference is just a reference. So means that in order to respond to your second question, is that we are doing DNA testing using PCR. Yes, and we are automatic of those problems using machine learning algorithms as well. Through you see a video, you see we see the pattern of the DNA. You see according to the weights of the molecular. Yes, but we always think how we know that this result is good or better than the intuition or the art that the medical doctor has.
Oh, yeah.
Yes,
you do need to work with them.
Yes, so but talk with people. We talk with the people from you see, from medicine is quite difficult. So we thought maybe we could do, you see, with a data set we found in another part of the world. If you see to me that what data set we are using, we took a data set that is in the network in one of the hospital in the United States. And from that, we reproduced this method. And now the next step, of course, will be compare our result with using DNA, you see, and this result in order to, you see, avoid the judgment of the clinical doctor. You know, yes, I know that exactly, you know, because my daughter, she worked in the urgency, yes, and she told me that, you see, their colleagues are very difficult. The position of the medical sometimes are, you see, they are very proud. They don't believe, you see, in technical issues. They don't believe in artificial intelligence because they are aware of that.
Yes, they are.
Yes, so this is one step. Yes, one step in related with that. Yes.
Fingers crossed it's going to work. I mean, I am personally have been very moved with this particular study that you guys did. I mean, it can save lives. It's a great breakthrough. I mean, VLC is very beautiful, the sessions that we had yesterday until today, but this one to me is very special. It can save a lot of people's lives.
Yes,
and we
yes, I will try to sell you. You see, another job that will come. You see, next or two more that we are using Harvest Wi-Fi.
I see.
Because how we detect the COVID? You know how we are doing? You see, yes, we are doing. We collect the toilet.
Oh.
Yes, we went to the toilet, and then we took some test there, and then we pass through the PCR machine, and then we are able to detect in institution, in a university, we are able to detect if there are PCR in the institution, and we find out that even sometimes you can see if there are drug abuse also.
Oh.
But, yes, but in this case,
that's what I meant. It may actually be as a solution to other things. It can bring other problems at the same time. It can expand the system. It's not only limited to COVID, although that's the main goal.
Because we are focusing on that only, yes. But and then we saw that, yes.
Okay.
I see. Best of luck. Fingers crossed.
Thank you very much for answering. So in view of the time, maybe a last question. Fabian, do you have one?
No, it was related with the same. It's about the new COVID, the new version of COVID, and with the vaccines and so on. It's showing different symptoms. So the thing is probably evolving, and this method, I don't know if
sure,
will
this
be
is very interesting paper and very interesting topic to continue studying and developing, because as Hussein said, it saves lives, so it's very important.
Thank you.
Okay, thank you very much.
Thank you.
In view of time, we're moving to the next talk. So Fabian can share the screen for the next talk. So the next talk name is Fuzzy Pit Controller Design for UAV Hybrid Energy Propelled with Differential Box. So the presenter is Cristobal Carreño, I think. Okay. Okay, so you can run the video, please.
It's a pleasure to be here. I'm going to present our work title Fuzzy PID Controller Design for UAV Hybrid Energy Propelled with Differential Box. This work was developed by Cristobal Carreño, Enrique San Juan, Pablo Adasme, Lucio Caniete, Fabian Segel, y Ali Degan Firuzabadi. The subject will watch are following. We start with the motivation of this research. Then I will explain how the propulsion system is composed. Then we will pass to the simulation model of the hybrid system. The fourth part is related to the controllers involved in the propulsion system and their design. After the result of this research will evolve. Finally, I will tell you some conclusion of this work. Every unmanned aerial vehicle powered by a propeller needs a power source. This power is delivered by an internal combustion motor or ICM. The coupling between power source and propeller is called clutch, as you can see in figure 1. There is some kind of power system uses two power sources instead of just one. His name is hybrid propulsion system. It is a combination of ICM and electric motor. The core of hybrid propulsion is the mechanical system involved in the coupling of power sources. From the literature, there are a lot of them exposed as secondary shaft dual clutch, secondary shaft single clutch, inline and planetary gear. The main problem from these mechanisms, they need servo motor to control the changes of power source. Not always possible to operate the both motor at the same time, and finally, for consequence, the requirement of control system are complex too. One solution to this is use a conventional gearbox in a reverse way. Instead of having one mechanical input and two mechanical outputs, it works with two mechanical inputs and one loud output. Our motivation relies on how to control the power sources delivered by ICM and EM at the same time in critical situations when the UAV is flying. Figure 2 describes how it works or simulation system. The equations of UAV dynamics are well known. A database with lookup table approach was made and his output is the power needed by UAV for flight requirements. The hybrid controller makes the decision based on the state of the charge or SOC of the electric source and the state of gasoline or SOG from the fuel tank. This controller states the power reference to both ICM and electric motor. At the same time, the controller decides if the electric motor works as motor or generator to charge the battery. Once the references are established, they are sent to ICM controller. The case for brushless direct current machine or electric machine is a little bit different because the machine can be charged by ICM. Depends on the main controller decision, electric motor can be worked as motor or generator. ESC or electric speed controller is the controller to drive the electric motor. Both power sources are coupled by a gearbox and then these energies combined are delivered to propeller. One model for differential gearbox is the available block in Simscape library from Simulink software. This block allows to connect two power sources and obtain the mixed energy. The velocity of propeller is the sum of velocities of electric motor and ICM. GD is the mechanical shape factor. The sign of equation 1 is due to the sense of rotation. Figure 4 shows how it looks like the simulation model of hybrid energy system. As I said before, two lookup tables deliver the dynamic response of UAV. A fuzzy PID controller contains the decision controller and ICM and electric motor controller also. Each EV block contains the combustion and electric machines. After that, gearbox block is inside the blue square and purple square contains the model of propeller. Respect to individual controllers from electrical machine, there are two linear controllers. The first one is dedicated to current control and the second one is in charge for rotational velocity. It should be emphasized both mentioned controllers just require PI compensators. On the other hand, ICM needs a PI controller because PI compensator is not enough to handle the ICM dynamic. The technique used for tuning phase was root locus. Equations 2, 3, and 4 are the mentioned compensators. Decision controller is responsible for the both combination from electric motor and ICM. For doing that, fuzzy variable consider are rotational speed from electric motor and ICM, state of charge or gasoline, and the error produced by a power on propeller and power obtained from gearbox. There are 5 fuzzy states and they follow Takagi-Sugino interference rules. As we can see at the right bottom corner, the probability function used were triangular shaped. For results, we studied two cases. First one is ascent scenario and the second one is descent scenario. For ascent scenario, with a low percentage of state of gasoline, but the total battery charge, the power delivered for electrical power is enough from some minutes as we can see in figure 8. For ascent scenario with low percentage, both state of charge and state of gasoline, the controller is not capable to compensate this, but in a critical case, the power drop is not so abrupt. Second scenario shows a low level of gasoline and all electric charge available in a descent trajectory. Figure 12 shows a good performance from the electric motor even when the gasoline level is low. Figure 13 and 14 describe the behavior of controller when the battery is over-discharging process and the well of gasoline is bad. As we can see, the power run enough to maintain a good level of power, but it makes a reaction to power needs. Finally, our conclusions are hybrid motor has the ability to select the speeds of the motor involved according to the state of each of the power sources. A general control fuzzy PID has shown good performance over critical situations. There is a big dependence of ICM considering the main power source, and this is the reason of drawbacks of the energy controller. This was our presentation. I hope you enjoyed this video and feel free for asking whatever you want. With the team, we will try to answer the question as well as we can. Thank you very much.
Okay, thank you very much for the presentation. I still, in this case, we have more minutes for questions. So please feel free to comment, to discuss. or to ask any question? No one? Okay, Ismael, you can ask.
Yes, thank you, Paulo. Yes, Christopher, I'm wondering if you have any, you see, relation you see with how you control from, how you control the system using a communication system. How do you go? How do you check that you see the or is a theoretical job?
It's just theoretical, but the main idea is to take the design of a PhD student at the University of Santiago. He made a physical mechanical system, and our approach is just to use his knowledge embed of the physics controller, and use that information to control the management of the energy. But it's just theoretical, but because the mechanical piece is not finished.
Yes, because I was expecting to see something related, you see, with the MIMO configuration, because this is a quite hard problem, you see, to transmit all that information, you see, in a, you see.
Yeah, it's MIMO.
You see a lot of bandwidth. Yes, and it needs a lot of.
Yeah, it's another term of research.
Yes, so you are contracting this, and then you will research on that, yeah?
Yeah.
Yes, are you about to use BLC?
Yeah, we pretend, but for example, for the landing, when the UAV is landing, there are some researchers that you can use some techniques to positioning the UAV or the plane for landing correctly, and use the information BLC to do the correct orientation of the plane, and do a successful landing.
Yes. This is one way to use it to overcome that. You see, bandwidth problem is to use a laser technology as well.
Yeah.
Yes, using free space optic.
Yeah. It's very possible. In fact, there are. I think I read some publication that research about the use of BLC at UAVs. It's not uncommon.
Yes, but the militaries have been doing a lot on that. Yes.
Yeah.
Of course, it's secret, but. Yes. Okay. Thank you. Thank you.
Thank you, Ismael. Maybe I have a question. How would it be do you think it can work well in practice, your theoretical approach in this paper?
One part it's the idea it's from at work that made the identification model of the engine. It's from an identification technique, so it becomes from a real approach, but it's not it's a lot of expensive realize that in the reality, so we have funds to do that, so that is the reason. But I think it could be really, but the technology and the electronics allows to you embed the physics controller at the microcontrollers or something like that.
Okay, and what other kind of approaches could you try, for example, instead of using fuzzy logic or things like that?
The main approach is just use the knowledge of the people that knows well the phenomena of landing or ascending or control. Because if you use a UAV, okay, the autopilot works very well, but the pilot, it's very necessary. So our main approach is just to use that information of the pilot, an experiment pilot, and embed it to the controller of the UAV.
Okay, thank you. Any other question? We still have some minutes. No one? Okay, if there's no question, then we should move to the next presentation. So the next presentation is the paper geolocation techniques in LoRaWAN networks as a fault tolerance approach in GPS-based tracking devices by Andre Francisco Pastorio and Edson Tavares Camargo. Okay, Fabian, you can please run the presentation.
I'm Andre, and I'm going to present my work, Geolocation Techniques in LoRaWAN Networks as a Fault Tolerance Approach in GPS-based Tracking Devices. I'm going to start talking about IoT and the motivations and objects of this work. I'm going to explain a bit of LoRaWAN and geolocation techniques, passing to the results and conclusion. Internet of Things aims to transform everyday devices into smart objects by equipping them with sensors and actuators that communicate over the Internet. IoT have several application domains like smart cities, smart homes, and smart health. In the context of smart cities, we have public transport, logistics, intelligent traffic, and fleet tracking. In these applications, the GPS is commonly used for tracking. They are very accurate, but they consume a lot of energy. For connectivity, LPWANs stands out, like LoRaWAN. Talking about failures, if a device fails, it can cause financial loss or even put people in danger. So fault tolerance techniques are necessary to mitigate these damages. Taking this into account, here in the city of Toledo, Paraná, the university has a partnership with the municipality that aims to track selective garbage collection trucks in the context of smart cities. Sometimes the GPS connection with the satellite is lost, making it impossible to track the truck. So, the objective of this work is to propose and evaluate a fault-tolerant solution for a GPS-based geolocation system that utilizes a LoRaWAN network. LoRa is a proprietary radio frequency technology based in the chirp speed spectrum modulation and mimics the physical layer of a LoRaWAN network. In the image, we can see a typical topology for a LoRaWAN network. About geolocation, we can use different approaches to locate an object. In this work, we use RSSI and TDOA because they are parameters easily found in a LoRa packet. Through RSSI, we can estimate the distance between the transmitter and the receiver by this equation. By combining it with Pythagoras, we have a set of equations which solve the location of the transmitter. TDOA, in turn, work with difference of the time of arrival on each receiver, making hyperbolas where the intersection between them is the location of the transmitter. As related work, the work of Poddevin achieved an average accuracy of 200 meters in a LoRaWAN network, that later was increased to 75 meters. Manzoni used RSSI in an indoor environment, achieving up to 20 meters of accuracy. Vargas and Peterson obtained an average of 100 meters of accuracy locating a target device.
We realize that the context influences on the accuracy, being the great accuracy in the indoor environment. Also, it's very common the use of different techniques that try to increase the accuracy. By this, our solution aims to mitigate the GPS data. In the image, we can see the flow of our proposal when a new link is received. Check if the GPS could find a coordinate. If no, check if 3 or more gateways receive the message and then calculate the location. The device used to track was the TTGO T-Beam and 3 gateways to act as receivers. For geolocation, we used RSSI and TDOA with Python algorithms, and LoRa Cloud API for comparison. The solution of the equations were approximated by least squares and by Taylor series. The error could be calculated between estimated and received with the inverse Haversing formula. The testing environment were set in a neighborhood of the city, and in the image we can see the position of the antennas. And we used two different configurations, SF7 and SF10, with packets every 30 seconds. Here we can see the positions of the device received by the GPS in the SF7 configuration. In these images, we can see in red the positions calculated with both algorithms by TDOA. In the same way, here with RSSI. Here you have the positions calculated by the LoRa Cloud API. In the SF7 configuration, TDOA achieved the best accuracy of about 18 meters. Now the results of SF10 configuration in the image, the GPS positions, and the calculated positions by TDOA and RSSI. In this case, LoRa Cloud achieved the best accuracy. We conclude that TDOA and RSSI are the techniques that stands out in LoRa geolocation. And the solution proposed achieved an accuracy up to 150 meters. And it can be used as an alternative for tracking in applications that don't require high accuracy. For future work, we will repeat the experiments when all 5 gateways are installed. Apply a technique to match the estimated positions with those we expect. We can also use the inverse Haversing equation directly in the calculation. Also, machine learning can be applied to estimate the position. Thank you for your attention.
Okay, thank you very much for the presentation. I think these last two presentations have been shorter, so we have some minutes for a couple of questions. Okay, Professor Alexander.
Oh, okay, thank you for the presentation. Just a question on this accuracy, André. How many LoRa devices have you used, or how many devices have you used to take the measurements?
Hi, thank you for the question. Yes, I use 3 gateways. They act as receivers, right? And 1 device to be tracked.
Okay. Do you think that what could be done to improve this accuracy? Don't you think that's a bit over the acceptable accuracy range that you do have for this application?
Yes. As you can see in this image, this work was made in the pandemic, and the municipality was supposed to install all the gateways in the urban area of the city. So by the pandemic, they couldn't do this, and I was going to work and working on this project, on this research, and I installed the antennas and the gauges here in my house and friend's house, and the position wasn't very good, wasn't ideal, right?
Okay.
So we had in the future, later this year, I suppose, they were going to install this in better locations with high heights, right? Then really high to give better view, better signal, better strength of signal. That this could really improve the calculations, the precision.
Okay, but then you have estimate that you, if you change the number of devices that you use for the tracking and for the localization, and also for positioning different heights, you would get a better accuracy.
Yes, we believe that will be very better.
Okay. Okay, thank you. Yeah, thank you.
Okay, thank you, Professor Alexander. Fabian, you can ask.
Thank you very much for your work. It's very interesting how you do the fault tolerant approach with different technologies. And some question about regarding the application, about a few others requirements that your application have, not only in accuracy, which is the accuracy that you will try to achieve in the future when you will have the antennas with line of sight, but also the refresh rate or some other characteristics of your positioning system. If you can give me some details just to...
I think I don't understand the question.
Yeah, because you have different characteristics of a positioning system. Like, for example, the accuracy is one, the refresh rate, it means how fast or how frequent you must get the position information, robustness in terms of standard deviation, etc. And for the specific application that you are using, which are these requirements demanding or are just...
Yes. So here in the application we are using as a study case is the garbage collector. So the people here in the neighborhood leave the trash in the street, expecting that the truck will pass and take the trash. So sometimes what happens is that the driver doesn't know the exact route to make and take the trash, and they just pass another street and the trash stays there for a long time. So I think that about talking about the refresh rate, it doesn't need to be very, very high, because when we talk about LoRa, they say like we don't have to use all the time in space, they say, because it's like a good practice to do, to leave the space in the bandwidth to other people use too. So talking about the refresh rate is this. The accuracy, I guess it doesn't have to be too high to the person that leaves the trash have to know that the truck is close to their house, to know if they can leave the trash outside to be taken. Okay. I don't know if I answered your question.
Yeah, thank you very much. And another small question is about the antennas. If you will now, when the pandemic will be over and you will be able to put the antennas in the right places, how did you compute those right places, the places that will have the best line of sight conditions? So on.
Yes.
How did you do that?
here we made a simulation. I don't remember the software we used, but we tried to put antennas around the city to make the best coverage. So the software, used a map, and we could see the strength of the signal in each position, and we are guessing through the simulation that it will be very good coverage.
Okay, thank you very much.
Thank you for your
Thanks,
question.
Fabian. So Ismael, want to ask a question?
Yes, I just want to, do a recommendation, for Andre. There are a very good data set in the network, Andre. And from that, you can, compare with your local solution. Because you are stuck at the moment, in a particular problem, this very local solution. So if you see your problem a little broad, how the people of Florianopolis, are doing it. Yes, it could be very interesting. I will send to you through the internal some papers. Yes, of Professor Christian. Yes.
I appreciate it.
Okay, then. Thank you.
Okay, so if there is any other question, we still have time. But I'm going to ask you as well about the same question Professor Alexander asked you about the error you handle in this type of system. How many meters and what kind of applications do you think they are most appropriate for this for your study, for your investigation?
Yes, I guess this tracking device, this tracking is supposed to, I guess the best is when the object doesn't move too fast, right? Because LoRa, in some cases, it takes time to the message to arrive at the gateway, and then this needs to be processed, and the calculations have to be done and then sent to the application. So I guess it's a good study case that we have here with the garbage collector. But other, I guess, maybe in some cases that you don't need the refresh rate, a high refresh rate. With some, I saw something about tracking pets, like cats and dogs, when they leave the house, and you put this on the leash, and you can see sometimes where they are when they leave the house. This is something that we don't need a battery, right? A high battery, I mean.
Okay, but how many meters are we speaking about in this type of application? 100 meters, 250 meters?
About the high error?
Yeah, the higher and the smaller.
Yeah, the high error is supposed to be at 300 meters.
Okay.
When we have the gateways properly set and with the accuracy of the clock, really good.
And the smaller, 0?
The smaller is supposed to be 0 when they
Okay.
but we know that
no error.
No error, okay.
Impossible, right? Do the interferences and the obstacles in the way of the sign, right?
Yeah, there will always be small error. Okay, thank you very much. Any other questions, Ismael? You can ask again.
Yes.
You have some minutes.
Yes, yes. Andre, are you using timestamp?
It's some kind of timestamp that comes with the signal of the GPS in the gateways. When the signal came, it came with a component of time.
Yes, because you have to introduce timestamp in all the process in order to process using artificial intelligence. Yes, so I suggest to you to consider that in the simulation programs.
Yes, this was a problem at first when we are talking about synchronization, right? And in this case, we don't need the synchronization with the tracking device with the gauges. We just need the synchronization between the gauges.
I'm not sure about that. Yes, if you are working with temporal series,
yes,
you have to always consider. You see the timestamp. It's a big issue. Yes. I mean, you simplify a lot, and then you lose a lot of control if you don't use that.
Yes, we believe that with some kind of machine learning techniques, we can.
Yeah, because you have to use temporal. Huh?
Yeah.
Temporal series. Yes. Okay. Thank you.
Okay. Thank you, Ismail, again. Okay. So if there's no other question, we can move to the next presentation. It is in this case it is the keynote speaker. It is Professor Ali Khaliji. I will give a brief bio of Professor Ali Khaliji. He is currently an associate professor with the École Centrale Marseille and the head of the telecommunications and antenna processing team at Fresnel Institute. His main research areas of interest include signal processing for wireless communication systems with an emphasis on the physical layer aspects of free space, underwater, and indoor visible light optical communications. He has served as technical program committee member for over 25 international conferences and workshops in the communications area. He was vice chair of WG2 of the FP7 Cost Action in Optical Wireless Communication, and is currently the project coordinator of European Training Network on Visible Light-Based Interoperability and Networking. Okay. He's currently serving as an associate editor of the IEEE Transactions on Communications and IET Electronic Letters. Also, he was the guest co-editor for Elsevier Optic Journal and the co-editor of the book Visible Light Communication Theory and Applications, published in 2017. Okay, so we welcome this to Professor Ali Khaliji, and Fabian, you can run the presentation, please.
Speech on augmenting Internet on the World of Things by visible light communications. I'm Ali Khaliji, Associate Professor at the École Centrale Marseille and Fresnel Institute Research Lab. And I give this talk on behalf of a number of collaborators that I had in the past, colleagues, PhD students, postdocs, and also other collaborators that you can see here. So first, some words about my research to introduce myself better. The Fresnel Institute lab is located at Marseille city in the south of France. And in terms of workforce, we have about 90 permanent staff from 3 institutions: Aix-Marseille University, CNRS, which is the French Center of Scientific Research, and École Centrale Marseille, which is my employer, in fact, and about 90 non-permanent staff, including more than 50 PhD students. So we have, our research is focused around 4 main fields, starting by information photonics, and we have different research axes here, starting by optical communications for IoT, which I am responsible for, teledetection, information processing and applications, and disordered media, and the 3 other fields concern more or less optics and electromagnetics. So we have electromagnetic modeling, advanced imaging, and nanophotonics and components. Well, our activities around optical communications for IoT concern 3 different axes, I would say. Firstly, outer free space optical communications that you can see here, some illustrations and some related works. We've been working on interbuilding high-speed connections that you can see here, and more recently on optical relaying and drone-based relaying for FSL links, as well as FSO for high mobility platforms, for example, high-speed trains. Then we have been working also on we've been working on indoor visible light or infrared communications, more specifically on multiple access and handover for Wi-Fi networks in smart city, smart factory, and outdoor applications. Also on smart healthcare, we've been working on the use of optical wires technology in medical wires body area networks. And also the management of dimming for indoor VLC communications that can see the illustration here. And every time you have the references if you're interested to go more into detail. And finally, we've been working also since more than, I would say 10 years on underwater wireless optical communications. So we have been working on channel characterization modeling at first, and then we have worked on more practical aspects such as pointing error modeling and mitigation, and also how to increase the range and speed of communications for such links. Well, that is the outline of our talk. Firstly, I will explain more the context, which is Internet of Underwater Things or underwater IoT. Then I will give more detail on underwater visible light communications, and then present some recent works on improving link performance in terms of range, data rate, and robustness. And then a few slides on experimental works, and then I will conclude my talk. So here you see the general picture of underwater IoT with a number of nodes here that could be underwater units, sensor nodes, and also some platforms that could serve a gateway, or you can have also backbone links and so on. So here you see in such a context the need to wireless links underwater, of course. So for these connectivity requirements, as I said, could be between underwater sensors. That could be simple sensors or seismic sensors, sonars, cameras, etc. And then we have the step of data mulling from these sensor networks by means of an AUV, for example. Then we can have the need to communication between underwater units. It could be submarines, autonomous underwater vehicles, what we call AUV, or underwater drones. Or alternatively between a remotely operated vehicle, ROV, and another unit. And we can have other requirements for divers, buoys, gateways, could be boats or ships, etc. And the applications, of course, there are a number of applications which are gaining increasing attention, such as sea exploration monitoring, for oil, gas, mining, environment, and so on, for security, real-time control of underwater robotics, etc. And the emerging applications that I just mentioned above are mostly they need high data rates and low latency more and more. So here you see some illustration of the typical use cases: data mulling by an AUV from underwater sensors, communication between high-speed between a submarine and an AUV, also different links between different underwater units, sensors or divers and so on. And you see this step of monitoring pipelines, for example, by means of ROVs and also AUVs and so on. All right, so what are different technologies for underwater communications? There are RFAs attenuate very strongly in water, so they're not really suitable for long-range communications. Most of the time, they're investigated for docking AUVs to submarines and data uploads, something like this. And important considerations concern antenna placement and design. And in the past, we've been using RF waves at very low frequency, VLF or ELF bands, for example, just to inform how to say a submarine to come to the surface to establish a high-speed RF link. Well, the typical, and I will say by default, technology is acoustic communications. We know that the acoustic waves have very low attenuation in water, and we can have link distances that can go up to several kilometers. But we have a number of challenges with acoustic communication, due to low propagation speeds and consequently large latencies. We have a low data rate, could be a few kilobits per second over tens of kilometers. We need large antennas, highly power consuming, and we have high external noise level, and we're subject to multiple dispersion, signal fading, and also there's an important impact on marine life. About optical communications, the advantages of optical waves are that they have a very high propagation speed in the water. We can have very high data rate, so low latency, high data rate. Power consumption is much lower than acoustic communications, and we have, especially in deep sea, low external noise level. But the challenge is that we have a strong attenuation in water due to absorption and scattering. So this limits this technology to medium to short range distances, and the requirement of line of sight, except for some specific configurations that we can use scatter light and backscatter light for communication as well. Well, here you see the loss of absorption coefficient as a function of wavelength for underwater communication. That is for pure sea waters, and you can see that in the visible range we have the minimum attenuation. To be more precise, the minimum attenuation is for ultraviolet wavelengths. But you should know that if we increase for increased turbidity, these characteristics is changed. I mean, for working under more turbid waters, we should increase the wavelength to have minimum absorption. Well, so the principle of underwater VLC is like any other optical communication. So it's very classical. So we have information processing and encoding everything, and then you have the modulator using an optical source, which is usually an LED or laser diode, and then we have perhaps optical amplification followed by informing optics. And most of the time for the current technology, intensity modulation and direct detection is used for most systems. And as I said, for transmitter or optical source, you have two options: LED with the modulation frequency about megahertz or tens of megahertz. The low cost can be easily arrayed, and we can have very easily multi-watt output. And these LEDs are suitable for relatively short range communications. For longer range, we should use laser diodes with smaller beam divergence, but which will require precise alignment at the same time. And they are faster. You have modulation frequencies about gigahertz, and precision bandwidth, sorry, and they're a bit more expensive than LEDs. So what are the challenges for underwater VLC? So the first, as I said, is the high attenuation that we have in water due to strong absorption and scattering. The limited bandwidth of optoelectronics, so that is not limited to underwater VLC, but in general to optical wireless communications. A big challenge is link misalignment and pointing errors that we have in underwater, because we have very low localization accuracy at the same time. And also in some specific condition, under specific conditions, we can have problems with oceanic turbulence. Well, about the channel, a few words. So we have a given channel loss, but the loss depends on the density of organic and inorganic scatters. There's a number of bio-optical models which have been proposed in the literature for that. In terms of channel delay dispersion, except when we work in very turbid waters, highly turbid waters, we can say that the channel dispersion is practically negligible. That is, the channel frequency flat. And most of the time, we're concerned with weak turbulence or even negligible turbulence in deep waters. Well, so I said that we've been working on channel modeling characterization, which is a very preliminary and important step before studying or designing underwater VLC systems. So there are a number of methods or approaches to model the channel or characterize the channel. Of course, we can proceed to experimental measurements, which are expensive, but which are the best way, I would say, to characterize the channel. There are analytical methods based on radiative transfer equation, RTE, and then statistical methods based on Monte Carlo simulations, and there are also approximate analytical methods based on Beer-Lambert model, depending on if the source is collimated or non-collimated and so on. So most of the time for design of underwater links, people assume the approximate Beer-Lambert model and then focus on more practical things. But really characterizing channel precisely for every condition is something very, it takes a lot of time and it's something very delicate. Well, now I'm going to present some works that we have done in order to improve the performance of the underwater VLC links, starting by range, trying to extend the range of this system because, as I said previously, this technology for the moment is used for short to medium range communications. So let's focus on the receiver side because most of the time the range limitation comes back to the sensitivity of the receiver. So we can use an APD, avalanche photodiode, at receiver size in linear mode, but if we use it in jigger mode, we'll have extremely high gain for the APD that we'll call SPAD, single photon avalanche diode, because actually it will be able to detect single photons, and but the bandwidth would be a little bit more limited than for linear mode. That is, we can have tens to hundreds of megahertz bandwidth for the device. So the other option, which is for the moment classical option, is PMT, photomultiplier tube. The advantage of PMT is that we have a large active area and very high bandwidth, and also very high gain, up to 10⁶. But the drawbacks are that they are very sensitive devices, require very high bias voltage, they're bulky, expensive, very easily damaged from exposure to bright light, and they have limited lifetime, and so on and so on. And we've been working since a few years on a new, I would say, generation of photomultipliers that we call silicon photomultiplier, or SIPM. They're also called MPPC for multi-pixel photon counters. These are the dense array of stats, as you can see in this illustration. They're put in matrix and then connected together. So the advantage of these devices with respect to PMTs are that they're solid-state devices. That is, we have good mechanical robustness. We need a very low voltage for biasing them, typically, I would say 20 to 50 volts. And they can detect very low light. So we have roughly the same gain as for PMTs, that is around 10⁶ as internal gain. But the drawbacks are that these are very nonlinear devices. They get saturated very easily. We have a very small active area, relatively, compared to PMT. And we need regulated temperature for stable operation of these devices, especially to reduce the dark noise. And we have a number of noise sources associated with the function of these devices. So what happens is that every SPAD, as I explained previously, will be able to take a single photon, and if this photon do not hit at the same time, the same pixel, I would say, the number of generated pulses or count values at the output of the SIPM will be proportional to the incoming light. So that's why we can interpret incoming light into we can have some notion of amplitude related to the light intensity, I would say. Then we have some, I don't want to go into detail of electronics. We have some quenching devices associated with each pixel. And given that if each pixel acts as an on-off switch when the photon is received or not, we have a dead time after the avalanche of every pixel, which is the time for the pixel to be recharged, during which it's not possible to detect any incoming photon. And due to the integration considerations, most of the current devices are based on passive quenching technology. And that means that we can have a more or less important dead time for these devices. And for the same reason, given that we have a limited number of pixels, if the incoming intensity is too high, the device gets saturated, which is the case for relatively short ranges. Okay, let's have a rough, comparison between PMT and SIPM-based devices. Here you have a very classical communication transmission link, information-based modulator on LED, that is a transmitter. Then you have the aquatic channel. And at the receiver side, you have PMT or SIPM-based receiver, preamplification, a low-pass filter, and sampling and demodulation, which are very classical. So we take into account the limited bandwidth of the LED, which is transmitter, and the SIPM, which are about 2 megahertz and 10 megahertz respectively. And we consider 1 watt transmit power at the, for the LED, weight to 10 degrees half angle. And we have considered very classical components for SIPM and PMT. You can see in this table, just roughly, very quickly, we have number of stats, which is about 10,000 pixels, and yeah. And here you see, for the case of uncoded OOK with extinction factor of 0, and data rate of 1 megabit per second, the bit rate plus versus the range, Z in meters, for 2 cases of clear waters and coastal waters. And what you see in blue is the comparison between the case for PMT, when you use a PMT for clear waters, for example. And if you look at the same performance for SIPM, we have this plot. And we can see that we can have more than 60 meters of more, let's say, longer range for PMT-based receiver, which is basically due to the fact that we have a much larger active area for the PMT. And the difference is logically smaller for coastal waters. So definitely PMT is more efficient, I would say, but due to practical implementation aspects, SIPM is a very, very interesting alternative to PMTs, of course. So let's now focus on the limitation of data rate. So how to improve link performance in terms of data rate. As I said, due to the limited bandwidth of the optoelectronic components, namely transmitter, LED, for example, and receiver SIPM, the data rate will be limited. So just to give you an example here, consider the case of uncoded OOK once again. What you see here is pulse of bit rate as a function of the data rate in megabit per second. Let's focus on the dashed lines, and I will explain these two other plots later. You can see that by increasing data rate, the bit rate increases, which is due to the fact that we have limited bandwidth, namely 2 megahertz for the LED and 10 megahertz for the SIPM. And due to the intersymbol interference and decreasing SINR, we have an increase in the bit rate, as you can see here. Here you have the plot for 3 meter range and 30 meter range, and here for 40 meter range. So the question is how we can deal with the frequency selectivity of the aggregate channel. So a very classical solution is to do equalization, but rather in frequency domain to reduce the computational complexity, or we can use multi-subcarrier modulation like optical OFDM. So once again, these are very classical in VLC or optical communication systems. So if we consider frequency domain equalization, I just focus on the receiver side when before equalization, we do an FFT, fast Fourier transform, followed by channel equalization to frequency domain, single tap, and IFFT before doing demodulation, demapping. And once again, I put this slide. That is what we get after equalization. And you can see that, for example, if we take Z equal to 30 meters with FDE, we have a neat improvement of the performance. That is, if, for example, we set the bit rate, target bit rate to 10 minus 4, without equalization, the range is about 12 meters, and we can increase it to 35 meters. The data is about 12 megabit per second, and now we can go up to 35 megabit per second in terms of data rate. Excuse me for this mistake. Yeah, the other option is to use optical OFDM. So it's we can use a rather classical DC bias OFDM. I think most of you are familiar with that. So very quickly after quantum mapping, we impose Hermitian symmetry, then IFFT, we add the CP, we scale the signal before adding the bias, which will pass through the LED and will be double cycle clipped before driving the LED. And then at the receiver side, after removing the CP and FFT, we once again do one-time equalization before doing signal demodulation. So let's again see what we can have as performance improvement. Here you see the bit rate plus versus range, Z in meters. For two cases of DC OFDM with 4 quantum modulations and OK. Yeah, for different data rates. And for OK, you have dashed lines. You can see here 1 megabit, 2, 5, 10, 15, and 20 megabit per second. And you can see that practically after 10 megabit per second, you cannot use OK, and your range will be very limited. Just I explained it also, I opened the parentheses to explain what happens here. In very short range, you have the effect of saturation of your SIPM. That's why your bit rate increases here. And we can define the so-called low bit rate interval. For example, if you say that target bit rate is equal to 10 minus 3, for the case of OK with 10 megabit per second, we can have interval of roughly 40 meters, where the system will work with low bit rate. So if you look at the case of DC OFDM, so we have the same spectral efficiency, of course, the same data rate. You can see that now we can very easily go to 20 megabit per second and having very large LBR. So that once again shows the efficiency of the proposed technique, DC OFDM. Of course, other variants of the optical OFDM can be used in this context, such as LACO, ACO, and so on. And you can refer to these references if you're interested to see more. Well, and lastly, let's talk about links robustness. So we can have different phenomena which impact the performance of the link. Firstly, it could be due to solar noise when we are working at relatively shallow waters, because we are using very sensitive detector, and even moderate solar noise can make that receiver get saturated very easily. So that is something to take into account. So I'm not going to go into more detail. We can refer to this reference if you're interested. And concerning noise, we can, of course, use encoding that's really classical in digital communications. You can see here the performance that we can get by only doing channel coding at the physical layer. So you see here the plots of bit rate versus range for uncoded OK, OK with Salmon coding, very classical code, block code, and also when using LDPC circuits code, and you can see that the important improvement that we can get in performance. And when we apply the coding also to the application layer, that is instead of FEC, we add also ALFEC on the top of that, then we can have a much more robustness for the link, for which you can go to this reference if you're interested. Another important aspect is link misalignment that could arise in different cases. You know, when we want to establish communication with an underwater mobile unit, we're concerned with the positioning inaccuracy or instability of the of the AUV, for example. When we're concerned with transmission with a fixed node at the surface, that could be buoy or a boat. We're concerned with the movements of this node as a result of the surface waves. And an important consideration here is to correctly model the channel and the pointing errors. So accurate statistical models are very important, depending on the application scenario. And then to reduce the link misalignment effects, we have considered different approaches. Firstly, we have worked on the suitable selection of the transmitter receiver parameters. For example, the transmitter beam divergence and receiver field of view. And also another technique that we have worked with colleagues from McMaster University was to explore the interest of angular MIMO, which has shown to be very, very efficient in short-range links. But unfortunately, I don't have the time to go into more detail. I'll just focus on the case of channel modeling for vertical links. So in this reference that you can see here, we consider buoy at the surface with an AUV beneath it, and communication in both directions, download and upload. Of course, I'm not going to detail all of the mathematical modeling here, just to say that for modeling the parameters related to transmitter, we took into account the speed of surface waves and also the stability of the transmitter. And for the receiver side, with optical Gaussian distributions for angular misalignments for displacement of the receiver with respect to the transmitter. So just to show you the interest of optimizing the transmitter receiver parameters, I show here the loss of outage probability as a function of receiver field of view and the Lambertian order of the transmitter. That's related to transmitter beam divergence, of course. And you can see here that we can have, at this point, we have the minimum P out, which corresponds to the optimum Lambertian order of 5 and the field of view of 14 degrees. And that of course depends on the parameters of the same misalignment. For example, for different surface wave speeds, denoted here by U, for example, 3, 6, and 9 meters per second, we can have different optimal parameters, different M and different field of views for the receiver, resulting in minimum P out outage probability. Well, a few slides on some experimental works that we have done in the past. So here you see some real field deployment of the SIPM receiver with LED transmitter on the AUV, which has been done by in collaboration with our Ifremer lessons colleagues. So you can see here the AUV equipped with the SIPM receiver, and here you can see some tests that we have done based on the wide VLC communications, and basically the objective has been to compare the performance of the Ifremer modem based on SIPM with the famous Bluecom 200 per DOC, which is based on PMT technology. And the results were very encouraging, and we could get roughly the same transmission range in different water turbidity conditions as for Bluecom modem. Well, and here you see some experimental works that were conducted in our research lab using a water tank and number of equipments to simulate different, to emulate different practical scenarios and to validate part of the theoretical studies that we are carrying out in our lab. Well, we come to conclusions. So you see here, we talk about the underwater VLC, which is a very promising technology for underwater IoT applications, for short to medium range application scenarios, and which can provide very high data rates. And it's also a very energy efficient technology, but there are a number of challenges still with the deployment of this technology for underwater applications. Firstly, due to the complex transmitter receiver design in the challenging underwater environment. Definitely a short-range, I would say, perspective is to design smart and adaptive transmit receivers to adapt to the changing underwater conditions and select the best transmission scheme or technique or detector, for example, depending on the turbidity, turbulence, and so on. And definitely, once again, what's sure is that underwater VLC cannot be the solution for every application, and it must be put together with complementary acoustic and RF links in an underwater IoT paradigm. And last point, typically people say that underwater VLC has no impact on marine life, in contrast to acoustic communications, but the real impact on the marine life is still unknown, because when you are using very high transmit powers in the blue-green wavelengths, that could impact the marine life very considerably. So that is something that should be explored for future. Thank you very much for your attention. If you have any question, please do not hesitate to ask me.
Okay, thank you very much, Professor Ali Khaliji, for such an interesting and original research presentation. We have some minutes for
Professor Pablo.
Thank you.
I should firstly thank you very sincerely for the nice introduction that you made at the first, and also apologize for exceeding the time, because I couldn't pack it more and didn't have time to repeat the video recording.
It's okay.
Sorry for
it's okay.
that.
It is very good. Okay.
Thank you.
Okay. So, any question from the audience, Professor Fari? Okay.
Yes, I have a. Thank you, Ari, for a very interesting topic and interesting presentation going into the detail. I have one or two questions. The first one is that when you talk about the energy efficiency of obviously this system, have you guys done any sort of detailed analysis on power usage of this almost self-powered devices? Because underwater, they've got to survive for so many hours or days and so on. Do you know whether any detailed analysis has been done in order to identify, for example, what should be the battery size, how much energy that one could use, and so on, and therefore the transmission side, which is the optic side, if I'm going to use LED or lasers and so on, then I can optimize that. It says that, based on this is basically the maximum power or maximum current you can be able to pump in order to elongate the length of the battery, so that these devices can stay underwater for longer period of time. Because I haven't seen in the literature this sort of information just to guide us as a system designer. Yes, I don't know whether you have anything on that you could share with us, please.
Thank you very much, Barry. So firstly, I've been working with some local industries and also IFPRI Research Center. And in our research, the focus has been on designing energy efficient systems, that is to minimize the transmit power each time. But when it comes to platforms such as buoys or AUVs, every time our partners say that it's not really a concern, the power consumption, because the part of power consumption that we have for having a transmitter 1 watt, for example, that is huge underwater, it's really negligible compared to other mechanical or motors and so on that we have in AUV or and so on, or in submarine, of course. But when it comes to underwater sensors, for underwater sensor network, of course, then there is a challenge, because the nodes should remain operational for years, perhaps 10 years, something like this. And then transmitting, the power consumption becomes a very, very important issue. But unfortunately, I haven't seen any detailed analysis on how much should be to quantify the power consumption and how much should be the transmit power and so on. But what's sure is that For the case of, if you take the example of underwater sensor networks, when an AUV comes to do data mulling, we should just wake them up for a short while. And optical communications, the interest of optical communication is that we can do the power transfer in very short time because the data rate is very high. And then we again push them to the sleep mode. So that allows to have a longer battery lifetime for operation. But
so
unfortunately,
Ali, there is a scenario that they don't need to continuously be operational. They can be operational at a specific time, send burst of data, and then go to the sleep mode and then do that again.
Actually, that's most of the time. The sensors that we use, it could be seismic or I don't know, very classical sensors that we use for measuring the pressure, the temperature, and so on. They need just to do a data acquisition, I would say several times during a day. So they just, and then they collect the data, and when for example, an AUV comes to do data mulling, they just switch on and transfer the block of information very quickly and then push the sleep mode again.
I see. But that would be a nice area, isn't it, to look into it, that this optimization of the power for these mobile devices within water and therefore design your optics system to meet that minimum or the maximum, the power they can provide you. Because I haven't seen that. It could be very nice in our projects, isn't it, to look into someone.
Definitely.
Yeah,
definitely.
Brilliant. And then my final question, Mr. Chairman, can I ask?
Yeah, of course.
Okay. Ali, what about, I know that you guys have worked on turbulence and so on. I mean, I guess the turbulence in underwater always exists there, isn't it? Because you have got water flow, because that's the nature of the ocean. Ocean are basically function because of, there is a water flow. So there is almost a continuous turbulence due to the water motion, isn't it? And therefore there must be some temperature differences in the water. And therefore that it's like having like a turbulence, continuous turbulence, but almost static and constant impact on the laser beam or LED beam, isn't it? Yes. Okay, maybe not change violently as you will have it in free space. So what is the long-term impact of that? And again, I know if it is a burst of things, it doesn't matter. If you're sending a burst of light, who cares about the turbulence? You can switch off and send it again, yes? But if it's a continuous, then I guess that there is a problem there, isn't it?
Actually, as you say, most of the time we are concerned with weak turbulence on the water. So it couldn't be as strong as what we have in FSO, in free space optics in the air. And that will depend highly on the link range and the distance, and also on specific, environmental conditions when you deploy your link. Most of the time, you're just concerned by what we call temperature or salinity gradient, in the variation in the gradient in the temperature and salinity of the waters. And the second factor is more important, salinity variations. And especially when you are concerned with the vertical links, then you have much more variation in the temperature and also in the salinity of water. But given that the underwater links, for the moment, the technology allows up to, I would say, 300-400 meters only to maximum of distance. Finally, the effect of all these turbulence will be weak. So most of the time, people go with very, with a weak turbulence regime. But at the same time, as you say, since we do transmission in burst mode, it could not affect more than that the link performance. But definitely, if you are long, I would say, communication within long time, a long interval, then that becomes a very important issue to address in practical situations.
Thank you.
I think I forgot your main question. Sorry.
No, that was it. It's just the fact that because if it is a burst of data at a short time, then it doesn't really matter, yes, because you can be selective in which period that you want to send, because you can sense the turbulence environment and then say, okay, don't transmit half an hour later or an hour later. you have that option because you are saying that most of them is sleep mode, and then active mode is very, very short period. Yes. So within that, therefore, turbulence becomes really irrelevant, I guess.
Okay.
If you're concerned with for example, in deployment in rivers and so on, you have much more flow of water, and then we can have potentially more, how to say, stronger turbulence. But there are a few works which started going to such studies, but the complexity of the topic is that you must go with true experimental measurements. You cannot just mathematically model such things, and that is something very expensive and takes time. That's why there are very little research on such.
Do you know whether from environmental impact, whether people have concern, especially if you're going to use laser beam in water, whether there are concerns about the power of the laser and the density of the laser beam in underwater, because you have got species in the water. As we protect human being in our domain, is there a concern that people are saying that, look, you cannot just keep firing laser in water because water is full of living things, yes? And I just wanted to know, as a side thing, whether people are basically raising alarm, and we should be aware of that. That's part of the sustainability, health and safety, and you know what I mean, that we should be very careful. And
that's a very, very important point, because most of the time we use blue and green wavelengths for underwater communication depending on turbidity, and these are the wavelengths where the marine animals have the highest sensitivity. And yes. For the moment there is no standard. There's nothing restricting the power of the optical sources underwater. The only thing people from time to time talk about is the same eye safety standard regulations that we have for humans for example in infrared or visible light. But definitely that is something that we have a lab in Marseille where the people work on biology aspects of the communication, and they are really going through the impact of all of these phenomena on the marine life, not only for marine animals, but also and fish, but also for microorganics and so on.
Yes,
that could be affected very seriously by such. For example, if you're using a levee, as you saw in the picture as shown, you have very large cone with a high density, blue color that could be very much damaging for marine life.
Okay, thank you very much for the answer and for the question. So maybe we have time, very short time for short questions. Ismael Soto wants to ask a question.
Yes, please. Hi, Ali. I'm wondering if can we use this technology to replace optical fiber? In Chile, as you know, we have a lot of earthquakes, and there are a research project that is deploying an optical fiber in order to predict the earthquake between the plates, Yes. Yes, and so I was wondering if maybe we could use this technology because it could be cheaper than deploy an optical fiber. Yes, and it's the same technology, no?
Yeah. Thank you, Ismail. Yeah, I was thinking first about the undersea cables. No, it's a very specific case that you're mentioning. I guess I'm not aware of the details of such approaches. But I guess based on lasers, underwater VLC, based on lasers could be good alternative to such approaches. But I cannot go more into detail because I don't know really the technologies they're using for such applications. But I would say that it could be a good alternative to such technologies.
Yes, it's people from France you see, and deploying this. Yes.
All right. I didn't know for you have two pieces of fibers perhaps that are aligned, and in case of earthquakes, you have some misalignments, and then they detect.
They have segment.
All right.
Okay.
they have cement. Yes.
Okay.
No, unfortunately, I'm not aware of this technology.
Yes, interesting. Yes.
Okay.
Yes,
Maybe it's fine. We
Thank
should
you.
have,
I will go through it definitely.
Our old friend, our beloved friend Tony, one of his hobbies was earthquake detection. If you go to his website, he spent huge amount of time developing algorithm of predicting earthquakes, and he has done superb amount of work, yes, in predicting earthquakes. If I think his still website is still available, and he puts all the results there. And we talked about this when he was visiting us, that whether we could use wireless light as a means of detecting the earthquake and so on, because his interest is to develop the algorithm of predictions and so on. But unfortunately, he's not with us.
Exactly, Fari. Exactly.
Yeah, it's
He loved Chile. He loved to come here. He was.
That's right.
Yes, yes.
That's right. So,
and he and you see, I misunderstood that at a moment, because we started joking with him. You see, because people from seismology, they never have model, they never have a prediction algorithm. Yes, I think he did. He did.
Yeah, he did a huge amount of work on it.
Yeah, because he worked in signal processing, and it was.
Because he used to send me. Sorry, I'm taking too much. He used to send me, say that, Farid, look, my model with actual location of the earthquake is very close. Okay, he's not saying that he's got the whatever, but this is what he was doing. He said that how close can he get his model to actually the location of the center of the earthquake and so on. And that is that was part of his research,
Exactly.
hobby. Yeah. Anyway,
okay, thank you very much for the comments and for the questions, but I think we are on time for the next presentation. Otherwise,
sorry,
we are not
sorry,
reaching all the presentations left. So maybe just a last question of 2 minutes from Arun, Professor Arun, maybe very short question.
I will just take 1 minute, to answer your question. Okay. It will take a long time, but I will address to Ferry's comments. First of all, the turbulence in water, that's a whole different ball game. The definition of turbulence in water is not the same as the turbulence in the atmosphere. Secondly, there is something called interface between the air and the surface of the water. That's an interface. That is a big problem. The probability density function of the laser propagated through that interface is a problem. Then finally, you go to the inside the water, that origin of turbulence in water is different than the origin of turbulence in the atmosphere. First of all, these are the 3 definitions. The typical applications have been many, more than 20 years ago, from a satellite to submarine communication with a blue-green laser. It started like that. And we have done some work in the last few years, actually, about the interface, probability density function, about the turbulence in water. All those things are published somewhere in proceedings of SPIE. But I just wanted to point out that turbulence in water has to be handled in a different way. But I have given some clues in some of the papers. If somebody is interested, they can look it up, and it can be solved. People have done it, and but we have to take into account of the 3 different type of turbulence: turbulence in the air, atmospheric turbulence, turbulence in the interface, and finally the turbulence inside the water. But anyway, I just don't want to take any much of your time. It has to be understood in a blue-green laser, about 440 nanometer probably. So, but those have been addressed, and I can address Ferry's questions in more details some other time.
Okay,
thank you so much. Much appreciated.
Thank you so much. Yes. Okay, we thank you again to Professor Ali Khaliji for the very interesting
Thank you for inviting me. Thank you very much.
Thank you very much. So, in view of time, we're moving now to the next presentation. Fabian, maybe you can share the screen. Okay, so the name of the next presentation is Acceptance of the Implementation of a Smart Campus Based on 5G Technology by Universities Constituents. Okay, you can run the presentation, Fabian, please.
Acceptance of the implementation of smart campus based on 5G technology by the university's constituents, which was carried out by researchers from 3 universities: University of San Juan, Argentina, University of Santiago of Chile, University of Technology of Brazil. The structure of the paper is the following: the first part motivation, second part introduction, the third part development, the fourth part results, the fifth part conclusions, and finally reference. Motivations. The authors consider that the contribution of this paper is based on the fact that the previous 3G and 4G technologies don't have the big data and artificial intelligence features that 5G offers to improve the communication research on a university campus. Introduction. This presentation systematizes the requirements of the user that circulate through the different space of a university campus that can be solved through the service offered by 5G. The methodology is based on the application of surveys to the different actors that circulate through the campus of universities in 3 South American countries in order to detect the exciting needs in each country. The aim of this report is to analyze the social impact that the emergence and implementation of the new 5G standard will have and how it will be used in the future. The implementation of the new 5G standard produced the needed society preparative foundations, which will lay the groundwork so that no one is left behind in this process, so that instead of widening the gaps, it can serve to improve quality of life of all people. The report examines technological concepts, new service, social impacts, geostrategic challenges, ethical and regulatory aspects, and concludes with a series of recommendations to unite their deployment with the social objective of improving the quality of life of all people. For example, Society 5.0 impacts on education show an increase in the capacity of online education through increasingly complex systems that allow teacher-students and student-students interaction, taking advantage of live video transmission of virtual reality, exactly that we have experienced during these months of virtual education or e-learning experience with the COVID-19 situation. These are the 3 campuses of the university.
We're having trouble with the...
I'm Liliana Martinez. I'm going to present the work called I'm Liliana Martinez. The report examines technological of life employment with the social on education show an increase in the capacity of online education through increasingly complex systems that allow teacher-students and student-students interaction, taking advantage of live video transmission of virtual reality, exactly that we have experienced during these months of virtual education or e-learning experience with the COVID-19 situation. These are the 3 campuses of the universities selected for the study. The users of the campus are receivers and decision makers. They are the actors who working or passing through the campus need of a smart campus in the actuality. The people who work in the campus are academics, people in charge of teaching and or research, but who do not have a management position or heads, administrative people in charge of the professional and or administrative management of the university operation, but who don't have management or leadership positions. Students, people who are end users of university service in the teaching area. The decision makers refers to those who are responsible for making decisions that involve or may involve obtaining information from different layers of sensory within the university campus. Here we can find the following groups: directors, academic or administrators who have the status of directors, or managers in whose performance the use of information from the campus can be a facilitating and efficient factor in making their decisions; and campus operators, personnel who must carry out the main task of campus maintenance, especially security and maintenance of toilets and gardens. The smart city have different dimensions: smart economic, smart mobility, smart environment, smart people, smart living, and smart governance, which impact on public policy. The different dimensions of the smart city have to be evaluated. The 6 key pillars of a smart city are smart economic, smart governance, intelligent environment, and intelligent mobility, as we show in the graphic. Methodology. The study design is non-experimental because there is no manipulation of variables or control of variables in laboratory settings. The target population for the surveys was 60 people evenly distributed across each country, who were administrators, teachers, researchers, and students who make up the university community in each of the countries. It is also a cross-sectional design, as it is a single measurement over time with no follow-up one, and it meant a survey under forms for the subjects in 3 different languages. The universe was constituted by user at San Juan National University in Argentina, user at Federal Technological University of Paraná, Toledo in Curitiba, Brazil, and user at USACH in Santiago, Chile. In Spanish, there's forms in Portuguese and in English. Results. The answers of the different actors which used the campus of the university selected to the study: San Juan National University, the Federal Technological University of Paraná, Brazil, and the percentage of campus users belonging to the University of Santiago, are shown in the following graphics. In this graphic, we present the answers of the users of San Juan University. Here we show the type of user of the Federal Technological University of Paraná and their answers. In this graphic, we can view the type of user, USACH Chile, and the percentage of their answers. This graph shows the comparison between the responses of the members of the 3 universities. Here we can view the different services in the campus. They need to be improved. In this case is the University of San Juan. In this case, we represent the different answers of the actors of the University of Brazil. We can view the different services and the need of improve them in the University of Santiago de Chile. Results show that among the possibilities that should exist on a university campus, most subjects prioritize that not only responding to the new technological paradigms is essential. Accessibility provision and delivery to all members of the university community should be present, respecting their right to access, stay, and obtain all services with equality. Thus, electronic accessibility will guarantee their educational inclusion. The expansion of 5G will enable rapid digitization, so it is foreseeable that people with different abilities will not be able to adapt to the pace of others unless measures are taken. Conclusions. Firstly, the systematization and analysis of the data obtained from the surveys conducted among the members of the university communities in different Latin American countries confirmed the need to optimize the service provided by higher education institutions. Second, it is also concluded that the use of new forms of systematizations, the use of exciting human and material research, prioritizing the implementations of 5G infrastructure should be promoted in relation to the students of the three universities. Examples, classrooms and laboratories. Thirdly, streamlining the flow of information related to the different areas to improve the organization decision-making process. Finally, the transition process must be promoted between 4G technology and the acceptance by the actors of the higher level educational institutions for the implementation of an intelligent campus which responds to the new paradigm of the 5.0 society, and it is supported by 5G technology.
Okay, so thank you very much for the presentation. We have some few minutes for a question, maybe. Fabian, you can ask.
Thank you very much for your presentation. I just have a small question regarding about which kind of improvement, because we saw many different applications where 5G and new wireless technologies can be used, but in which context, like increasing the speed rate, the data rate of the communication, or decreasing the energy, for example, that you use for transmitting data. Which characteristic of the communication system the people could be more able to accept, or they are willing to change or to accept?
Yeah, thank you. In our university, we have now only 4G and the very no good communication. But the needs, the situation during the pandemic, the COVID-19, shows the more needs about the circulation of knowledge, to access to the information, and we can accept that the situation need a challenge with a new system, with but we consider that the challenge we need not relation with the technology system. We think that this is a new paradigm, that the actors, especially the authorities who have to make decisions about the challenge in the different space, academic, administrative, and especially to the access of the students, different space as physical accessibility, but the more important need is to give them digital natives more of a better service in relation to the classroom, to the access to the laboratory, where in this moment not have a good connectivity, a good research, material research, and we can view that the teachers have to capacity or access to the different course to capacity about different possibilities that the platforms to learning have, and the university could implementations system called CET, who have the possibility, but the problem we could view is the resistance of the teachers of the area of administrative to make their activities, their task in this platform, in this online service. I think we have a great possibility, but we need the technology research. It is a problem, and it is a relation with the economic situation. But well, I need to continue researching about the new possibilities to access, to give a good service in different areas to the students, especially to the students who have disabilities, and to have the interest for go to the university to study a different profession.
Okay. Thank you very much for the answer. And in view of time, we're very short in time. So I will pass now to the control to Professor Paulo de Tarso to act as chair for the following presentations. Thank you very much to all of you.
Thank you.
Thank you, Professor Pablo. Professor Sebastian, will you be my partner now?
Yes, Paulo.
Okay. So, good morning for everyone. Let's start the last session in this Sacvlc. And the first work that we will see is has the title Novel P-median based formulation for maximizing coverage in 5G, 6G wireless network, with César Sandoval, Pablo Adasmi, Henrique San Juan, Ismael Soto, and Ali Derhan Firuzabadi.
Okay, let's go.
Good morning, my name is César Sandoval, and this is the presentation of our work entitled Novel P-median based formulation for maximizing coverage in 5G, 6G wireless networks. In this paper, we consider the problem of maximizing user coverage for wireless communication networks subject to facility location and radial distance constraints. We propose two novel mixed integral linear programming model based on a classical P-median problem. The novelty of our proposed model is the consideration of non-overlapping radial distance constraint between antennas,
In particular, our first model maximizes the total number of users, while the second one includes in the objective function the maximization of the user and the minimization of the number of antennas to be activated. Our models are based on the classical p-median problem. This problem consists of location p facilities of a largest set of candidate location in order to minimize the distance of weighted average demand between user nodes to their closest facilities. The p-median model in the classical formulation considers the objective function the minimizes of the distance between customer and facilities. In our proposed formulation, we also consider the distance between facilities by means of a coverage radius. Our proposed models also included non-overlapping constraints in order to avoid interference between the different transmission radius of the base station. In Table 1, there are some related works. To the best of our knowledge, our work constitutes a first attempt in the literature that includes non-overlapping radial distance constraint in order to deal with efficient coverage for future 5G, 6G wireless communication networks. We defined the following index sets. Each element in the radius set was generated using Formula 1, where P sub L is the energy consumption of the base station. PC area is the total energy consumption per covered area and is defined to quantify the energy consumption and efficiency for different wireless technologies. The variables were defined as shown below. We also defined the input matrix, the UPC, where each entry denotes the Euclidean distance between user and the base station. Similarly, we defined the input matrix, the UPF, where each entry represents the distance between base stations. In the model 1, 2 represents the number of users to be covered. 3 ensure that each user is connected to a unique base station. 4 ensure that each base station can use at most one radius. 5 ensures that the total number of base stations to be activated equals P. 6 ensure that the distance between the clients and the base station are less than the coverage radius allowed for each antenna. 7 ensure that the coverage radius cannot be overlapped, and 8 define the domain of the decision variables. We consider another alternative model that allows maximizing the total number of users while simultaneously minimizing the number of base stations to be used in the wireless network. In particular, we include a weighting parameter alpha. It belongs to the interval 0-1 in order to balance the degree of importance of each conflict objective term. Thus, the second model can be written as follows. The remaining constraints, 10 to 14, are the same as in the model 1. Python program was implemented using the Burovi solver with the following options. The CPU time limit parameter was set a maximum value of 1 hour. So far, we generated 24 instances with dimension of m and n. The radius vector r is generated with increasing value from 0 to 1 using a step sizes of 1 divided q. We also considered parameter value of p. We mentioned that this range of parameter value is chosen arbitrarily in order to ensure that hard instances are obtained. In another version of this paper, a broader range of parameter value will be considered. The input matrix, the UPC and the UPF, are generated by calculating the distance between customers and facilities and between the facilities themselves. The coordinates of each user and base station are randomly drawn from the interval 0-1. In Table 2, we present preliminary numerical results obtained with Model 1. Notice that the Burovi solver terminated with an optimal solution when the MIP gap parameter value equals 0. In Table 3, we present numerical results for the instant 11 using the second model, while varying the value of parameter alpha. We chosen this instant from Table 2 as it provides to be one of the hardest instants for the Model 1. In table 3, columns 1 and 2 show the instant number and the value of parameter alpha. Here are the details obtained for the second model. Finally, in columns 11 and 12, we show the number of customers served and the number of operating base stations obtaining in the optimal solution of the problems. In figure 1, we present numerical results in a graphical manner for both models used in the instant 11. Figure 1a shows the initial distribution of user and maintenance, whereas figure 1b and 1c represent feasible solution for the problem using both models M1 and M2 respectively. It's possible to observe from table 2 that the first instant where the optimum cannot be obtained is the instant number 10. This instant uses parameter value of P and Q and M and reports a mean gap equal 1.03%. If we compare with the scenario 4 in which we maintain the value of parameter P, N, and M, we can see that the only difference is the availability radius. We see that an increase the radius increases the CPU time required to solve the model. On the other hand, in the instant 13, 14, and 15, leave the infeasible solution, which means that these instants do not satisfy the constraint in 7 of model 1. This can be explained by the fact that there are very few set of candidate base station solutions. Otherwise, there are very few available radius to be chosen. On the other hand, on average, we see the model coverage 85% of customers. It is interesting to note that for the instant number 23, the site being the instant with the highest number of nodes would be find the optimal solution of the problem in less than 1 hour of CPU time, whereas the instant 11 present the highest mean gap value behind equal to 90.21%. In table 4, we observe that it's possible to reach the optimal solution of the problem with the exception of instance 1. On the other hand, unlike model 1, and regardless of the variation of the parameter alpha, the model 2 cannot provide a better solution than the model 1. However, it's also shown that it's possible to utilize a unique base station in order to cover all users of the networks. Our models consider as input the distance between customer and base station as well as the distance between the base station. For this purpose, we generate the coverage radius value in order to avoid overlapping transmission radial areas. The problem is motivated by the potential development of future wireless network application. So far, we noticed that the first formulation allows the obtain better computational result in terms of both the mean gap and CPU time values. The main contribution of the proposed model is that they can be used to analyze different scenarios while using different technology for future development of 5 and 6G networks. It's also worth mentioning that the proposed model allows and handling efficiently the number of radios to be chosen, although at higher computational cost. As future research, we plan to propose novel approximation algorithm and mathematical programming formulation in order to solve largest instance of the problems. The authors acknowledge the financial support for project and it funded it. Here present some reference, and that has been our presentation. And advance, thank you so very much for your attention.
Thank you, Cesar. We are open for questions. Anyone has a question to Cesar Sandoval? Anyone? Okay, the next presentation has the title.
Okay. Please give me a moment. Can you turn on your camera for taking a picture, please, before we continue? Thank you.
The memories, huh? For the memory of the online conference.
Yes,
Yeah.
to the memories. Somebody else?
Yes, please.
Buddy, please. You are the more important person here.
Sorry, I am one of the delegates.
In the news, it will appear in the news.
Yes, Ali, my friend. Eli. César.
Ali.
César.
César Azurdia.
César, yes. César Azurdia.
This is, I think the idea is that can everyone please turn on your camera if you are at your computer? Maybe some
Yes.
people have gone for a tea or
Yes.
coffee or so on.
Yeah, maybe they are not.
Yes. Fabian, switch your camera, please. Liliana, please.
Fabian.
Yes, very good. Liliana. Okay. Vicente, please. And Quique. San Juan, please.
Sí, aquí estoy.
Pon la cámara.
Sí, ya.
Yes. Vicente.
Hello.
Okay, my friends, I think we are ready, no?
Yes.
Diego,
Yeah.
the picture, yes?
Yeah,
Okay.
you can say cheese.
Cheese.
Okay, let me take
Another
another
one.
picture. Yeah, another one. Okay, say cheese again.
Cheese again.
Cheese.
Okay.
Okay, thank you.
Thank you all. Thank you. Good idea. Seba, you did well. Yes. Thank you.
You can continue.
Yeah, okay. So, Professor Paulo, continue, please. And thank you to Cesar. Good presentation. Thank you for your presentation, Cesar.
Sí.
Okay.
No problem. You're welcome. Sorry?
People are shocked. Too much. Too much.
Too much. Exactly.
Yes. Congratulations for your mother. Yes.
Thank you, my professor. Pablo Dasme.
Yes. I think this responds the previous paper question.
Yeah, I like math a lot.
That Fabian did. Yes.
more than telecommunication, I like math.
Okay, let's go on, my friends. Yes. Paulo, please take control. Yes.
Yes.
Okay.
Okay. The next presentation has the title Simulating Radio Coverage with Polar Coordinates for Wireless Network with Sergio Cordeiro and Pablo Adazzi.
Hello to all present. My name is Sergio Cordero, author of the paper, together with Pablo Dasme. The title of the paper is Simulating Radio Coverage with Polar Coordinates for Wireless Network from the University of Santiago de Chile. The presentation has the following point. To end with the conclusions. This paper presents a simulation study of polar coverage signal which can be applied to different current wireless communication systems. In particular, we use the polar radio coverage feature the radio mobile software. In this pre-case study, all parameters are configured for both the radio base station and mobile station located in certain point of the proposed coverage area. Introduction. As far as we know, there is no previous study analyzing coverage and signal level using the polar radio coverage feature of the radio mobile program in a strained area for cellular telephone, referring Las Condes and Valparaíso as high traffic areas. Propagation models. The model used in wireless network are model ATAL, model COS ATA, model COS Wolfich Ikegami, and model ITM. The following tile have their specification. The cell concept is a function of the area and the traffic demand to be covered or served. When interaction with other antennas, the hexagonal pattern will be formed by symmetry and balance, which understand the hexagonal pattern of a cell can be divided in sectoral probes. They use the directional antennas. Fig 1. Antenna radiation pattern. The radiation log this antenna is directional. 65 degrees of the station base. Fig 2. Beam width. It can be defined as the angular interval the width. The direct power density is equal to the maximum power in the main direction of the radiation of power beamwidth. Polar correlation simulation. The simulation considered two geographic zones in Chile. The first one covered an urban coastal area in San Antonio and seconded in the metropolitan region. The data of the transmitting station are shown in Table 4. The radio mobile program allows you to generate radio coverage plot to simulate how effectively antenna performance on the ground. Some steps must be considered to obtain the coverage plot. Fig 5. Coverage from radio mobile to Google Earth Pro. Fig 6 showed to cover the fringe cover has angle from 0 degrees to 65 degrees. Fig 6 polar coverage map urban coastal zone San Antonio. Fig 7 shows there are areas with a very low signal level, but all point-to-point links are what below. For the second coverage, Fig 8 shows the transmitter and receive point randomly distributed in the area with a high signal level rate, but the upper coverage has a lower signal level, including areas in the Andes Mountain, yellow, green. The data calculated for the fringe coverage in the town of San Antonio are present in the Table 5. Secondary are present in Table 6. Conclusion and the future work. The coverage simulated in the radio mobile program reflects the signal variation at different points, but with a fairly high link surveillance barrier, which is about the level of sensitivity in reception, affirming that the signal variation is in the acceptable range. As future reach, we plan the proposed mathematical optimization program, associated with the localization of the transmitter and the receiver for a wireless communication system and different geographical areas. Thank you very much.
Okay. Gracias, Sergio. Anyone has a question?
I have a question. I just want to know
Okay,
what is the key thing has been achieved? In other words, what has this research led to? Something which is measurable, either analytically, simulation, practically. What is the outcome? I couldn't get that.
Sergio, can you answer?
Profesor Adame,
He doesn't speak English.
sí, simulation predictive
Very good.
with
Very good.
radio mobile software and version 11 has an error 4 dB compared and reality in the Chile country zone and urban cost and different the 4 dB.
Let me try to enrich the explanation. So what Sergio is trying to do in this paper is an empirical study, and he's trying to find out for using real data from Google Earth. He's putting this data into the software Radio Mobile, and he's trying to find out what is the coverage for using this real data in 2 different zones of Chile, which is Valparaíso and Las Condes, I think. I don't remember exactly, but these are so. And as first approach, this is what we have done here is to try to find out the real coverage that it would. I mean, from the data, using real data, and later we want to try to use this real data and to put it into some mathematical optimization models to try to locate base stations in these zones. Notice that this data includes the terrain, irregular zones, and this is actually the main contribution so far.
What is this? Yeah, I mean I think that's interesting. You're using real data. What's the relevance of that to VLC? I couldn't understand. I can see that what is the relevance of this to
so actually,
wireless communication using VLC, and how would it push the VLC forward in terms of as a topic?
Yeah. This is actually this can be applied to other technologies as well. In particular for VLC, maybe we haven't addressed that yet, but I think it could be applied for scenarios in which we can use it. I don't know if maybe shorter range, maybe indoor scenarios in the zone, or I don't know if it doesn't work in outdoor, no? For example, when the day is with light, no? Maybe. Sergio, perdón, Sergio.
Sí.
¿Cómo se puede aplicar esto con VLC?
Para aplica el sistema free space optical en las link point to point, building zona urban system broadcasting TV, broadcasting FM, etc.
Pero para VLC, for VLC, do you think? ¿Qué aplicación? What kind of application?
Application para las link para link optical in FS optical free space optical principle.
Okay, thank you for the answer. Fabian, you have another question?
We have a question from Fabian.
Yeah, I have a small question regarding, you said that you can use this, for example, with free space optics to for example, in Valparaíso or many different parts of Chile, we have a very irregular and very harsh condition to put fiber and to deploy fiber And so in those places, you could use, for example, free space optics to provide coverage to the antenna, and then the antenna will provide wireless coverage to the area where the antenna is deployed. And also, how would you think that which effect on your planning will have the inclusion of UAVs, for example, for providing wireless services? Since now you can use the UAVs as an access point in the cities or in areas where wireless access is crowded or even difficult.
What is the question for Jan? Finally?
How UAVs will change these the parameters of your problem?
Sergio.
Parameter of the system antenna cable coaxial and parameters data elevation data SRTM1 software radio mobile.
I think Sergio has only tested the case for fixed base stations so far. So we really cannot answer what would it be to use unmanned aerial vehicles so far. Obviously, this will transform the problem into a much more difficult problem.
Thank you very much.
But so far, this can be applied. You know, this radio mobile software can be applied using any technology, but not BLC. Not BLC so far. So we will try to address that in the future, or try to see how it could be. You know,
it could be part of the BLC that if you use for as part of a massive IoT, you could think of this, that the uplink, the uplink could be VSC, downlink could be OCC, optical camera communication. So
yeah, maybe,
especially in farming or agriculture or industrial, open area industrial application, where you want to monitor things and so on regular basis and so on. You know, like asset tracking, you can track the asset by flyness of the things, and the camera looks at things, and each item has got, supposedly it's big manufacturing company, have got a very huge yard, and they've got machines and expensive items and so on. You know, each of them can have something to send, or the camera can pick them up, and then this can be done all using both infrared and visible light communication. You know?
Yeah, it should be part of future research, because the radio mobile software we are using does not include yet any BLC technology, actually, only radio frequency.
Yeah, I guess that's the reason why, you know, for us, we need to move into areas which are huge potential for this application. It's not always the indoor or back to back and so on. And yeah,
right. Okay, thank you very much for the suggestion, and we will take into account.
Okay, thank you.
Professor Paulo.
Yes.
Okay. Continue with the next keynote speaker, I think.
Yes. Can I present this?
Yes, we are in time. Thank you to Sergio and Pablo. Continue with the next presentation, please, Paulo.
Okay. Now we will see the keynote with Professor César Azul de Mesa. The title is Advances in Visible Light Communication System Applied to Underground Mining Environments. Professor César Azul de Mesa received the Bachelor of Science degree in Electronics Engineering from the Universidad del Valle de Guatemala, the Master of Science degree in Electro Engineering from Linnaeus University, Sweden, and the PhD degree in electronics and radio engineering from the Kyunghee University, South Korea. He joined the Department of Electrical Engineering, University of Chile, as an assistant professor, where he is currently lecturing on wireless and mobile communication systems. Professor Cesar Azulia.
Okay.
Hello, guys. Good morning. I'm here. So, good morning, colleagues. And I know some of you are abroad, not in Chile. So, good afternoon to some of you, and good night to some of you who are in Asia or other places. So, thanks for listening to my presentation. And I would also like to thank the organizers of the symposium for inviting me to present this research topic. The title of my talk today is Advances in Visible Light Communication Systems Applied to Underground Mining Environments. This is a project that was funded by Fondesit, which is part of the Chilean Research Agency. The funding started at the beginning of this year and will continue until March 2025. So the funding is for 5 years. And this work is being done with colleagues and students from Universidad de Chile, a colleague from Universidad Católica del Maule, which is in Talca, Chile, and a colleague from Universidad de Santiago de Chile, specifically Professor Fabián Seguel, as well as Ismael Soto, is also collaborating in the project. So once again, the title of my talk is Advances in Visible Light Communication Systems Applied to Underground Mining Environments. At this moment, I will turn off my camera in order to optimize the bandwidth of my internet connection, and I will come back again with my camera on at the end of my presentation. Okay, so let's proceed with my presentation. I will give a brief description of the things that I will cover today. I will give a brief introduction of the things that we're going to cover in this presentation. Specifically, we'll go through some general concepts of a BLC system, and then we'll go into details into the underground mining BLC channel model, which is an essential part of the project that we're working on at this moment. And finally, I will present some ongoing and future work regarding the project. And finally, I will present to you some recent publications that were recently submitted, and a couple of them we just got the acceptance letter. So this is where I'll be covering the next 20 to 25 minutes. So I will go over.
Sorry, the slides are a bit out of focus.
I believe I should not go into detail into what is visible light communication systems. In this conference, most of all of us, we already know and have worked with BLC systems. But I will once again give a brief description of what BLCs stands for and what it's used for, and some of its characteristics. Okay, BLC normally ranges from 380 nanometers to around 750 nanometers in terms of wavelength, and in terms of frequency, we are normally working around 430 terahertz to 770 terahertz. This is about 10,000 times larger than the entire radio frequency spectrum. It's a lot. If we were able to use all of this spectrum, the capacity of the system would be really large. But we have to remember that at this moment we don't have LEDs capable of managing all of this spectrum. So at the moment we're limited with the amount of spectrum that we can use of the available one depicted in this figure. As we can see, BLC, it's way up higher in the spectrum compared to traditional microwave or radio systems. So there will be some very particular problems that we are facing with visible light systems or in general optical wireless communication systems compared to traditional RF schemes. Okay, so some of the motivations of why we want to work with BLC. We're basically going to discuss very briefly some aspects of the spectrum, the density, energy, and the infrastructure already existing in this type of communication schemes. First of all, the spectrum. As I already mentioned, the spectrum is completely global and unlicensed spectrum, which differs a lot from traditional radio frequency systems where we have to use licensed frequency bands. This is not the case for BLC systems. Second, but real as well is very important is that since we are in a very different part of the spectrum, we are not interfering with traditional radio frequency systems, such as cellular communication systems, Wi-Fi systems, or any other traditional RF scheme. We are not interfering since we are in another part of the spectrum. We will not have interference problems with RF systems. The type of interference we're going to deal differs from the traditional ones found in radio frequency systems. Okay, regarding energy, since we are normally going to work with LED technology, this technology is relatively and it's very efficient in terms of energy consumption compared to the traditional and old bulbs we used to have a few years ago. So BLC, in order to be efficient in terms of energy consumption, we're going to be using LED technology. We are normally going to use global lighting standards. And finally, there is a reuse of the energy used for lighting. We're going to use the lighting infrastructure not only to illuminate indoor or outdoor systems, but we're also going to be transmitting data. So we are using the LEDs for two purposes: illumination and data transmission. Okay. Regarding density, during the last couple of years, LED technology has grown really fast. We are talking about around 550 million LEDs bulbs per year. We're also trying to combine the energy efficiency and wireless communications of these technologies. And nowadays, the implementation of LED technology is quite mature. It's a technology relatively cheap and very easy to buy and implement. Regarding the infrastructure of the scheme, we will have to implement new technology at a marginal cost. Since we are already using the existing lighting infrastructure, what we have to focus is mostly on the backbone, the connectivity of the system, which normally is being proposed and being done through power line communication schemes, PLC, or Ethernet, or another type of wired scheme. And of course, the maturity of LED technology, which is something that has exploded during the last few years. Okay, what do I want to depict in this figure? That not only there is academic interest in optical wireless communications, specifically visible light communications, as well as Li-Fi, but there is also an industrial interest. In this figure, we can see that there are many very big corporations interested in topics such as Samsung, Huawei, Apple, Airbus from the John Hopkins, Orange, which is a big operator in Europe, Cisco, Boeing, Sony, among others. So this is at this moment is far beyond just pure research. At this moment, there is industry interest in developing these technologies. So the ecosystem has grown dramatically during the last couple of years. Okay, now that I have introduced briefly what okay, now that I have introduced briefly what BLC is, some aspects, basic aspects of optical wireless communications and the importance in the industry, now we will focus on describing some basic things about BLC systems. Okay, first of all, I will provide some just general insights of a basic visible light communication system. For this case, we're assuming a CISO communication link, just one transmitter, one receiver, and its basic components. Okay, what we have here initially is a bit of a stream of bits that we want to transmit. Therefore, using several DSPs techniques at the transmitter side, we are able to modulate and code these input bits, and we are going to transmit them. Instead of using radio frequency signals, we're going to transmit them using light signals. In the middle, we have the communication channel, which, as we will see in the following slides, it differs a lot from the traditional radio frequency communication channel. And finally, in the receiver side, instead of having the traditional antenna that we use for radio frequency systems, we're going to have a sort of photodetector, or it can be a camera that basically converts the optical signal into an electrical signal. After we have the signal converted to current or voltage levels, we can use DSP techniques once again, and we are able to demodulate and detect the signals. So basically, what we have here are the most important, the big differences with traditional radio frequency schemes are at the transmitter side, where instead of using the traditional antenna, we are using an LED, which will convert the electrical signal into optical power. The communication channel is completely different, as we will see later on. And at the receiver side, we're either using a photodetector or a camera in order to convert the optical signal into an electrical signal, and then the processing. Okay, the light sources. Basically, to model this, we are using the generalized Lambertian radiant intensity. And as we can see here in figure A, basically, depending on the angle, it's the it gives us the relative luminous intensity. As we can see, we have around 100% when we have an angle of around between -10 to 10 degrees. So this is a very important issue when working with these systems, and this angle is going to be very important when we design the systems and evaluate the transmission scheme. Okay, how are we going to model the source? Basically, we are using the normalized shape of the generalized Lambertian radiation pattern, where we have the Lambertian mode number, which is basically a relation between the angle that we're using and regards to a logarithm relation. And the angular distribution of the radiation intensity pattern is given as follows. And this is basically a relation between the transmitted power and the Lambertian mode number, and as well as the angle that we're using. Okay, at the receiver side, we will have normally a photodetector, and a very important parameter that we need to use is the effective area of the detector. This area that we can see here is extremely important and is basically a relationship between the angle of the incident angle and A sub P. And another important factor that we're going to work with is the optical gain of the photodetector, which is given in this equation, which is once again a relationship between the angle and finally we can see the angular characteristics of the photodetector. Okay, now that we have characterized the transmitter via the angular distribution of the radiation intensity pattern and the light detectors, we're going to start focusing on the channels. First of all, we're going to talk about the line of sight DC channel gain of the channel. Here, what we have is the transmitter, the LED, and the receiver, a photodetector. Which are the important variables here? The two angles that we have described previously, the one at the transmitter side and the one at the receiver side. Initially, and as an initial approach, we are assuming that the vectors are normal, which is the ideal case, and we have that distance between the transmitter and the receiver side. And we have different heights depending on where the LED is placed and as well as the photodetector. So the line of sight DC channel gain is given as follows, which is basically given in terms of the M mode, the area, and the angles at the transmitter and at the receiver side, as well as the gain. So this is the one of the important parameters of the channel characterization, which is the line of sight length. Okay, what else can we see at this point? Remember, since we are in an indoor system or indoor environment, we, besides the line of sight length that we analyzed previously, we also have non-line of sight links, which is the one depicted here. What can we see here? First of all, we are assuming regular walls. Yeah, this is for a traditional indoor environment, which is basically the way it has been modeled in the literature. We will see later on that in mining environments, this is not the case. We're normally dealing with irregular walls. So what do we have in this case? We can see that for the non-line of sight, first of all, we have that the light travels to the wall a certain distance. Next, comes into the wall and then bounces back into the photodetector. Therefore, we have two traveling distances. The one initially from the LED to the wall, and now this distance. So normally, this will generate some delay of this path that is traveling through the wall. It's this delay compared to the line of sight link. We can see that we have several angles once again, the traditional one that we analyzed previously, but now, since it bounces off the wall, we have a new angle. This important, since we're assuming in this case and in this model that we have regular walls, we can see this vector. Okay, but as we will see later on, this will normally will not happen when we're working in underground mining tunnels. And finally, we have once again the angle at the receiver side of the photodetector. And we have once again the different heights according to the system that we're revising. So once again, the non-line of sight DC channel gain is given in terms of the N mode, the area of the photodetector. We are assuming that there are different reflections in this in terms of the non-line of sight length, and we are considering all the angles that are participating in the non-line of sight length, which is first of all this angle. The second one would be this one, as well as this one. So we have to consider this scheme in terms of the geometry of the way the light is traveling through the environment. Okay. Okay. So to conclude, what we have seen normally in BLC ideal indoor environments. First of all, we have the photodetector, which in this case we're placing over the helmet, which in general can be anything, machinery, cars, vehicles that are moving through the mine, but in this case we have placed it over a helmet, and the LED. Why are we saying it's ideal? Because of the normal vectors. Okay, and at the non-line of sight link, we're assuming that this vector behaves this way. So what we have at the receiver side, we're assuming a system that behaves this well. Of course, we will have the component of the line of sight of the system for the distance between the LED and the photodetector, and we will have the reflections of in the wall, that in this case it will travel this distance initially, and then it will travel this distance. So in the ideal scenario, we're only assuming the line of sight link, the non-line of sight link, and of course the noise, which is natural of the system, which is normally the thermal noise and shot noise, which is characteristic of these communication systems. Okay, so keep this in mind. This is for the ideal scenario that we have seen in the literature, only assuming line of sight and non-line of sight links, and remember the normal vectors. This is an ideal scenario. But what happens when we're working in underground mining DLC channel model? First of all, we're considering several variables that were not considered in the ideal case. First of all, we are going to assume that the LEDs and PDs are tilted and rotated, which were not the case in what we saw in the previous slides. Secondly, we're using non-regular tunnel walls, so this will generate some changes in the way the non-line of sight link propagates. We'll analyze random shadowing, which is produced by machinery or people walking through the tunnel, and of course there is dust in the tunnel, so there will be scattering. So at the transmitter side, what can we see right now? That this vector is not normal anymore. It has been tilted. So the geometry of the system is modified. It will not be as easy as what we saw in the previous slide. We have to do some adjustments to the geometry of the way the light is being transmitted, because now the LED has been tilted, which is normal in underground mining scenarios where the LEDs or the lighting is mounted in the tunnel. Okay. And at the receiver side, once again, we normally do not have a photodetector that is completely normal. The photodetector or the optical camera at the receiver side is normally tilted. So the geometry changes as well. So there is a rotation and tilt of the photodetector, as well as rotation and tilt of the transmitter. So this changes the geometry. And in general, the LOS channel expression for underground mines is given as follows. It changes a little bit compared to what we saw previously, and it's basically based on the angles that we are working on in this system. We are not assuming that the system is perfect as we previously saw. Okay. Second, the non-line of sight. First of all, in this figure, we can see what has been assumed in the literature for a perfect case where we're assuming regular walls. You can see that the reflections are normal to the walls. What happens in underground mines? We are working with regular walls. Therefore, the vectors are completely random. Therefore, we cannot assume the ideal case. We have to assume a random vector, and this is due to the nature of the walls. So this is how the non-line of sight expression appears, and we can see that the nature of the expression varies according to the angles. Basically, in this case, to the tilt of the angles that we're working with. Okay, so what do we have at this moment as an initial approach? We are now assuming that the LED at the transmitter side is not normal. It has been tilted. Same applies for the non-line of sight link. We're assuming irregular walls, so we have a tilt of the angle, and the same at the receiver side. We are not assuming that the photodetector is completely normal. We're assuming that it has been tilted. So now the scenario has changed a little bit geometrically. What else happens in these scenarios that was not normally not considered in traditional indoor environments? Shadowing. Due to the nature of the wavelengths used for visible light communication, shadowing can completely block the line of sight link or even the non-line of sight link. So we need to model this. Therefore, what we propose is using a Poisson process to describe the appearance of objects in the underground mining DLC system. Basically, we use a weighing function in the channel model. This weighing function varies between 0 and 1, depending on how the signal is blocked. So at this point, we are modeling the effects of shadowing through the use of a Poisson process. Okay, and something very important that is normally not analyzed in indoor systems is scattering. This is basically due to the dust particles that are present within the mining industry. This is very common, and in this case, as an initial approach, we have used a unified scattering model, a two-dimensional model. Normally, when a photon hits a dust particle and scatters, its trajectory is altered before continuing to the travel through the atmosphere. As we can see right now, light travels, normally is traveling, and when a dust particle is found, it alters it generates certain phenomena to the light. Therefore, we need to analyze the scenario. And as an initial approach, we have used a two-dimensional model. As we will see later on, we will try to expand this model to a 3D model, which is more realistic. So this is the scattering component expression used in the system, where we're assuming an n tends to infinite, and this is the way we're modeling the scattering. Okay. Finally, after considering the line of sight length, which is given here, the non-line of sight length, and the scattering, and of course, the shadowing, which, as we previously mentioned, it's a weighing function that affects the line of sight and non-line of sight component of the system. And of course, here I forgot to indicate that we need to add the noise natural to the system, which is basically a thermal noise and a shot noise. Okay, so all of this work was done last year and through this year, and finally we were able to publish this work in this journal in the special section on communications in harsh environments of IEEE Access. And this work was, of course, done with colleagues from Universidad de Chile, Universidad de Santiago de Chile, as well as colleagues from other universities. So this was the initial approach for this channel model. And these are some of the most important results. We are looking at the CIR, the underground mining, for different positions, and we can see different effects that we have. And here is the CIR with the reference scenario, which is normally the traditional BLC indoor system, and this is the proposed scenario, where we can see that there is a big difference, and we can see that there is also a big difference at this point. So this is the main findings of what we have done during the last year of the project, and we have obtained this model. Okay, now that we have an initial model, what are we working on right now? We need to enhance the existing model. We need to consider other shadowing and scattering models. As I previously said, the initial scattering model that we were using is a two-dimensional one. So at this moment, we're trying to develop a new model using some techniques for constructing a three-dimensional model in order to enhance and see the real the effects of scattering in more detail. The initial model was initially designed for a single input, single output BLC system. So there is a master student at this moment working on designing, analyzing, and validating a BLC MIMO channel for underground environments. In parallel, a couple of students are designing a simulation framework which considers IEEE 802.215.7 standard and considering the proposed channel models. So we are trying to construct this simulation framework, assuming and considering the indications given by the standard and evaluating it in terms of the proposed channel model. In parallel, we're also constructing an experimental testbed because at this moment we only have the analytical and simulations of the system. We need to validate this experimentally. So we are working on this experimental testbed. Hopefully, by the end of next year, we'll have something working on. And in parallel, there is a colleague from Universidad Católica del Maule that is helping on designing and analyzing channel estimation techniques to enhance the performance of the system. Okay, future work. As I mentioned, we need to do experimental validation of the proposed channel models in a real underground mining scenario. This probably will be we'll be doing this next year, since we'll probably have access to a real underground mining tunnel. We need to obtain experimental statistics of the position, rotation, and tilt of the optical receiver, as well as, and of course, develop empirical models. We also need to obtain experimental statistics of the rotation and tilt of the non-flat walls of the underground mining tunnel, and develop empirical models once again. And finally, we need to design and evaluate optimum diversity combining schemes in a multi-cell VLC system using ADRs, which is something being done by one of our PhD students. He's working with ADRs at the moment in order to optimize and enhance the system, mainly in the receiver side. So some recent publications of the work that we have been doing. First of all, with colleague Fabian, of course, Pablo, and some colleagues in France, we were able to publish this manuscript called Underground Mine Positioning and Review, where we cover some of the mine positioning techniques using traditional RF schemes, as well as using optical wireless communications. A manuscript has been recently accepted for publication. It's called Performance Analysis of IEEE 802.15.7 based visible light communication system in underground mine environments. In this case, we have enhanced and extended the original channel model, considering other shadowing distributions. And this has been done for according to what is given by the standard. At this moment, we also have a manuscript submitted as major revision, and where we're analyzing the effects of ADRs in VLC systems. And in parallel, we have a manuscript that has been submitted a few weeks ago, and this is basically where we do some analytical work. We're trying to, we derive some close expressions for the VR for the model, for the channel model that was previously proposed. This is assuming imperfect CSI in the system. Hopefully we'll be getting good news in a couple of weeks regarding the status of these two manuscripts. And finally, I would like to thank everyone for listening to my presentation. And now I'm ready to answer some questions or to enhance our conversation. So thank you very much, and thanks for attending the conference. Take care, guys. Thank you very much.
Thank you, Professor Cesar. It's a good work. We are open for question now. Professor Arun.
Oh, sorry.
It's a very interesting presentation. I learned from the very basics to the most advanced stage. My one question is, so after your study, how that helps to avoid an accident in mine?
Yeah. Just one thing, Cesar will be connecting. He has some internet problems, so I will answer since I'm also part of this project. I will be answering for him if he can connect. Basically, optical wireless communication can be used in two different ways inside the mine. The first one is to provide local area network or personal area network services, and with those services you can provide also indoor positioning. Okay, and with indoor positioning, you can prevent accidents since you know where machinery is, or also the miner workers. So you can prevent accidents between the mobile machinery and the worker, or between the machinery, since they are aware of their position inside the tunnel. Okay, that's the first one. And the second one is that using free space optics in the ventilation tunnels, which is another project that where Ismail is involved, using free space optic in the ventilation tunnel, you can increase or increase the robustness of the nowadays communication infrastructure, because nowadays they have optical fiber cables, and since there is mobile machinery inside the tunnel, often it happens often that this optical fiber is broken because of accidents that happen inside the mine. So the free space optics will, with a small deployment of devices, a small amount of devices that can be deployed, it could help to increase the robustness and provide backup for the main network, for the main communication network. So you have both of them that could be useful to not to prevent, but to be aware in case of an accident, and also to prevent the accident.
Okay, thank you.
Cesar is here.
Yes, I'm here.
Any
Sorry, guys.
other question?
No,
I have a question.
I'm here. Sorry, guys. I was having parallel lecturing that I couldn't miss today, so I'm sorry.
That's okay. Thank you. Thank you very much for your presentation. So my question is as follows. In a mining environment, you have two scenarios. We have the major part of the mine, the shaft part of it, where you have got the distance between your access point and the machinery and human being could be on average maybe 10 meters, 5 meters. Then you have the open area, which is a chamber where you have possibly the height could be, I don't know, 10 meters and so on. So the distance could be slightly larger. So when you do the channel modeling, which is, I think is interesting, what is it that you are after in terms of telecommunication point of view? What is it concerning you that we need to go to the detailed channel modeling in a very closed environment where the communication distance is so short that raises a question of the, the question is that what is the need in terms of system modeling, that we need to understand it better, because let's say that we want to send hundreds of megabits of data, and therefore we know if we don't understand the channel, and therefore we're going to have a lot of ISI or delay spread and so on. So when you are doing your modeling, what was the motivation behind it? Yes, that addresses the issue, the major issue that exists in underground mining, and therefore doesn't allow you communication system at a certain speed to take place. If speed is not relevant, then from your point of view, from your experience as a group, which are doing really, I think it's an interesting piece of work, what is the direction in this tunnel and use of VLC in terms of channel modeling? Or should we look at the modeling of a network within the channel, ensuring that data are basically arriving at the destinations and so on and so on? So I like you to sort of, maybe you can share your experiences with the audiences, that, what was the reason for doing this?
Liang, would you like to answer first?
Yeah, probably because as a group we don't have the same ideas. Probably we also have this kind of discussion when we are trying to model and came up with different kind of solutions. So for my point of view, my personal point of view, I think that there are two different applications or models of the channel that they should be or could be useful nowadays in underground mining scenario. The first one is the free space optic channel model in the ventilation tunnels, which have different conditions depending if is the tunnel with the inflow of the air or the outflow or taking the air outside. Because the first one is very clear air and the other one has a lot of dust, particles, and so on. So we haven't done any model of free space optics, even though there are some articles in for example, Vicente, I know he published one in a sandstorm, how the optical camera communications behaves in a sandstorm or with this kind of very harsh environment. But we don't have that with free space optics in underground mines, which could be useful for us, and we will try next year to come up with a model. And the second one could be also the optical camera communications in the case of V2V on V2X inside the mine, since all the trucks, all the vehicles inside, they already have cameras, they have the light. And to provide this kind of communications in the underground mine, again, is different because we have dust, and this dust is different from the dust that we have in the highways or in highway tunnels. So to come up with those models for me would be very interesting. For this, for the article that we published, we try just to see how or have a first approximation about the parameters surrounding the mines, like the dust, a fair approximation of how the link will behave with the dust in suspension, and also how the reflection of the multipath will change because of the walls are not now straight, are irregular. And also in the, for example, in positioning algorithms, it will have an impact, this new multipath model and scattering model. So for my point of view, these two applications or these two models are the things that we should in the future look after. But each one has a different opinion, and we always discuss about this. And
my personal view is that I think we shouldn't. I don't think we should worry about reflection, because mining ores are so rough. You get very little reflection. Yes. I think the concept of, you might say that, look, we are trying to minimize the amount of illumination from the light because we have a power constraint. So therefore, transmitter signal to noise ratio is limited. And therefore, I need to understand the channel because it's going to affect the signal to noise ratio of the receiver. And therefore, we are going to optimize it. And therefore, we're going to compensate for anything in the channel at the receiver side. Yes. And therefore, you need to understand the channel transfer function in order to be able to use, let's say, use neural network, machine learning, and so on to compensate for that. That, to me, is a very interesting research. Because you have a purpose here. The purpose is that the lighting is limited in terms of intensity in mine. If it's true, I don't know, because that's not my area, yes? And therefore, you're trying to save energy as much as possible. And therefore, you're compensated by that by bringing intelligence into the system, and therefore knowing the channel transfer function is absolutely vital. For example, if you use a camera, then you can do a lot of image processing concept by knowing the transfer function, and then you can use equalizer, all that you need to do that. I think, to me, that is great research, yes, because the purpose is lack of power. If, for example, that you are going to use a shaft in order to send a laser beam to the surface, yes, and then again, He said, okay, I'm going to use the laser beam. Laser beam needs current, therefore needs generates power, and therefore needs intensity. And again, you're saying that we are going to use a very, very low power laser for this reason. However, between the laser and the outside world, the power loss due to the channel is so huge because of the dust particles. Then we need to understand this, you know, in order to be able to, can we compensate at another side, you know. I think this sort of a story, to me, it makes sense. So people now beginning to understand the harsh environment of tunnel, kilometer down the ground, underground, to ensure that viability of the communication system at all time, that your link availability is 24 hours a day. Yes, that is there. So therefore, to me, I honestly don't think data rate is not that important, because these things are actually quite short packets of information. So you can, you know, you're not worried about that because you've got huge time and so on. Unless you might say, well, you've got a huge data you want to transmit, just like what Ali was saying, that you can choose a specific time of the day and fire a laser beam, and it will send tens of gigabits of data to the surface. Problem solved. But most of it in the underground, which is made about the health and safety of the people and the machinery being okay and so on. These are all short packets of data, maybe kilobits of data, not more than that, yes, that you're trying to capture at some regular time, not all the time. That was my point, you know, but I think it's interesting to look at that. The interesting from my final comment is that, honestly, there's a lot of work has been on shadowing in indoor and blocking. I think that I like the scattering part, which is very similar to underground. You know, really find out what happens to photons as it hits the dust particle. What percentage of them will propagate along the main propagation path, therefore receiving at the photodetector, which is very small. That modeling is very interesting. Mathematically, as a curiosity, is very interesting. Someone practically said it's not significant. But as a concept, it's fantastic to come a model will predict the path that the photon might take, and therefore will arrive. And I think that distribution would be fantastic to have, you know, analytically. Thank you. Anyway,
just two minor final comments. As you know, the Chilean economy moves around mining, so we have encountered that the mining industry is now interested in BLC. One of my PhD students, he got an award from Codelco, which is one of the largest mining industries in the world. So we're gonna have access to an underground tunnel probably next year to make the measurements.
Yeah, I've seen it. I've seen their tunnel.
So probably next year we'll have access to make the measurements.
Yeah, me and Ismail were there some years ago. We went down to the tunnel.
And secondly, I didn't mention, yes. So I didn't mention it in presentation, but what Fabian said is right. For next year, we have budget for also trying optical cameras, because initially we were only working with photodetectors, but we're also considering the use of optical cameras. So
yeah,
there is a lot of work to be done. We're happy about that.
Sure. Thank you, guys.
Ismail, final.
Yes, can I make a comment in order to complement the words of Cesar and Fabian? In a channel model, we are not agree, as Fabian said. There are different perspectives. Yes, and you see, actually, we are moving in a, you see, in a mine. We have a project with Fabian, and then yesterday our student went there to take the picture, because we will check check if you see a LoRa one for, you see, for a small for, you see very for, you see, for delay for a slot network. And also we have the, you see, the free space optic in the for the shaft. Yeah? And also we are doing, you see, positioning and with camera, yes, with artificial intelligence. And also we, maybe you saw when you came here that we've been dealing with, you see, with high power amplifier, and we did large power device in order to have a LED with 1,000 watts, and we did some proof of that, yes, and we can reach sometimes 100 meters, yes. But the problem is that it's too bright, so people can be blind. And also we've been searching, you see, in different metric. I remember that last year in Tehran colloquium, I presented, you see, a metric based on music. Remember that? Yes, yes. It's another, but in the case of frequency rather than you see this theoretical model that we have, because this model is I could say is a mix between radio frequency and BLC. Yes. So at the moment, as Cesar said, we are realizing that we are thinking that artificial intelligence is one of the next steps that we will do, you see, to solve the problem of positioning, because Fabian did that in France. You see, mainly, you see, to use the Raspberry, as Diego showed yesterday. This is low power computers in a border in order to compute, you see, in a body of the people, and try to process underground. Yes, still we don't have, I see my colleague, or we are agree, still we don't have the solution. And I hope you see that in future, you see, using intelligent words like Fabian is doing as well. Intelligent, yes, we can improve, you see, or solve this problem, you see, of underground mining. Yes, it's a how you say, is quite interesting challenge. The government is delivering money to our group. You see, Cesar got that. Fabian is promoted one, and I got a big project for next year. Yes, and so I would like to invite to all the audience to contribute with us. Yes, and in the next future we will do a postdoc call, and so we have plenty of problems that we have to solve. Yes, plenty of problems, and we are not very clear with that. Yes, and so I don't want you see to be very long, but next presentation, you see, our student Jose will present you see, a quantum technology for EOT, that a work that we do with Cesar and Sacvlc. Because most of the algorithm are based on the numerical crash. But if we go for you see, quantum theory, the algorithm reduces the complexity a lot. Yes, and so I don't want to just see to go deeper in this discussion. I think we have to. Someday we will invite you and Professor Aaron, you see, to come, you see, after this pandemic, to talk, yes, and find solution for all the problems that we have in our country and related with the copper. Not only the copper, it's rare earth as well. So, thank you, Cesar. Thank you, Fabian.
Okay. As Professor Soto said, the next work called a quantum key distribution using optical frequency come source, written by José Azoca, Ismael Soto, and Fabian Vinicio Corral.
Hello everyone, I am José Azoca, and I will be presenting the paper entitled A Quantum Key Distribution Using Optical Frequency Comb Source, work done in cooperation with Ismael Soto, Fabián Corral, and César Azurdia Mesa. Here is the agenda. First, a little introduction, then clarify the objectives, and present what is an quantum key distribution, QKD, and an optical frequency comb source. Then we present the results in section 4 and 5, in which we present the data construction and the implementation of the protocol on an IR laser. And finally, the conclusions. Well, in the communication, there are several duties and compromises we have to follow. One is ensuring the information of the security that flow in our channels, and two is the use of the efficient use of the resources. That is why we come to a approach of applying the QKD scheme for generating a key to encrypt the data, and the optical frequency comb source is for applying techniques of multiplexing for use the same medium. Right. Our objectives are basically two. One is present the QKD scheme for a client-server pair that can be used in a channel that use a multiplexing technique, and the other one is generating a multiple client-server pairs over the same channel, secured by the resulting key for each pair. The BB84 quantum key distribution protocol is a protocol that provides a way for two users to share a secret key or a possibly compromised channel. In this system, there is a sender conventionally called Alice and a receiver conventionally called Bob. Alice and Bob expect to communicate with each other securely by sharing a quantum channel and an authenticated classical channel. Here is a basic example of how the BB84 protocol works. Let's say that Alice wants to send a series of bits to Bob through the quantum channel. Alice has the option to encode each bit in a base for depolarization, vertical, horizontal, or diagonal, represented in this case by a red cross and a green X respectively. Depending on the bit and the polarization base choose, that the different state of the qubits are generated, represented in this table. When the qubits arrive at the receiver, Bob has to make the decision to measure each qubit in a certain polarization, which he must do it randomly, because he has no way of knowing in which base Alice choose to polarize the qubits. According to the law of physics, if he chooses correctly the same polarization in which Alice encodes the qubit, he has 100% probability of recovering the bit. Otherwise, he has a 50% probability of correctly recovering the bit. The result is taken as a quantum key when the qubits are measured in the same polarization in which they were generated, which in this version of the protocol is achieved within a 50% rate when measuring the qubit randomly. In addition, if there were a third party intercepting the qubits from point A to point B, this third party usually called Eve, at the time of measuring the qubits must also do it randomly and then forward the qubits to point B, with the intention of not being detected, but by doing this, and according to the law of physics, the polarization state of the qubit will change. So later, when Alice and Bob compare the polarization base used, they will realize that the error between the generated and the measured qubits will be greater than the usual 50%, so it could be detected that there is a spy in the channel. Here we present our implementation of the VB84 protocol. This implementation is programmed in Python, and the two channels are represented in this case in sockets, in two different sockets with different directions. For generating let's say a final key of length 10, in this implementation we need to generate at least 40 different qubits. That's say first Alice sent all the qubits generated to Bob for one channel S2. Then for in another channel, Bob tell Alice what basis he used to measure. Then Alice keeps the bits that were measured in the same basis and tell Bob what the basis were correct. Then Bob keeps the bit that Alice indicates and send Alice a sample that is for check at the error rate. If the error rate is superior to the usual, it will be necessary to take the necessary countermeasures. If everything is okay, the bits that were used to check the error are discarded, and the final key is generated. That's in Alice. Then Alice needs to send a confirmation to Bob to discard the bits that he sent, and finally the key is generated in Bob's side, and he sent a confirmation to Alice that she can send the information encoded with the final key generated. Well, an optical frequency source generates a large number of wavelengths, x-phase in frequency and equal amplitude, ideally all of which are phase log and therefore synchronized. The difference in frequency between two adjacent modes or lines is known as spacing. For example, in this case, is 0.081 nanometer. This, by the way, this is only an example of an optical frequency comb. And when is desired to maintain an amplitude equalization in the generated comb, as like in our case, different schemes are available. One of them is the one present in here in Figure 4. It's a hybrid scheme combining an intensity modulator with an electro-optical phase modulator. In addition to the two modulators, this optical frequency comb source has an RF synthesizer, an electrical phase shifter, and a variably gain electrical amplifiers. The single wavelength input light is modulated in the modulators by the sinusoidal electrical signals generated from the synthesizer. For the data set compression, here we show the result of the spectrum of a continuous modulation with varying the RF power, while increasing the RF power of the electro-optical phase modulator, increase the number of spectral lines generated. In this figure, we basically have a basic channel with only one caret, but when we vary the input power of the E on PM, we have two different lines of the spectrum that we can use for represent the two different channels needed for the QKD. And going forward, this figure was made by using some data analysis techniques. And the figure 5, we can shift the spectrum and make the representation of two different client server pairs. Here is the programming scheme of the protocol for implementing on an ER laser. In the right boxes are the S2 two channels represented, and the yellow boxes are the S1 channel represented of the figure 2, and the white boxes are the function and part of the algorithms that represent the rest of the algorithm. And here we present the results. First, we managed to successfully generate a key of 100 bits using only one server pair. We can see that it's the same key. And here we managed to generate two different keys for two different client server pair. Also here the bits are equal, like correspondingly equal. And here we present the probability of detecting an if in an of detecting if and in an eavesdropper in a man-antimidated attack. These results were made by Mr. Satya Goodman in 2018, and he demonstrates that we can exchange 20 qubits, that the probability of detecting an eavesdropper is more than 90%. And the conclusion for this work: first, a framework is generated for the quantum key exchange, specifically for the BBH4 protocol, while using a frequency comm source as a means to multiplex different channels for information exchange over the same medium. And the algorithm developed is not limited to the use of the frequency comm, so it has the potential to be applied to other forms of multiplexing. Regarding to these results, the channel established by applying the protocol is secure, since a 100-bit long key established in both of the server client pairs. It is safe to say that if there were a spy in the channel, it will be discovered, giving way to take the necessary measures, such as aborting the communication or changing the channel or start a new key. As a future work, it is possible to propose the scalability of the system, generating a system that can support a number of end-client server pairs, and the application of crypto system of the information that travels through the channel using the algorithms of encryption like RSA. That's it. Thank you very much.
Thank you, Jose. Anyone has a question? Diego. Diego has a question. Please, Diego.
Yes. My question, well, I'm an encryption enthusiast, so my question is relative to the fact of a part in your work, actually not in this presentation, that I was waiting for. When you in your work you refer to symmetric and asymmetric encryption, and it's not quite clear how these two types of encryptions relate to your work. So if you could please elaborate on that, explain it.
Okay, thank you, Diego. Well, the intention of that section where we introduced a very rich way to approach of the different types of encryption is to guide the reader to the future work that we are working on, that is to using the generated key to encrypt a larger packet of information traveling through the channel, and thus to be able to evaluate in a more practical way the security of the proposed system. That because in the work presented here, we are just comparing our system with the work which Mr. Kupa did in 2018.
Perfect. Thank you.
Thanks.
Okay. Anyone else? Okay, thank you. Professor Paulo.
Yes?
Okay, thank you, Jose, for your presentation.
Thank you.
Let's continue, Paulo.
Okay, the next work has the title Comparison of Different Machine Learning Techniques for PCE Estimation of Millimeter Wave Energy Harvesting Rectifier Device with Diego Dias, Esteban Toledo Mercado, Ismael Soto, Davi Zabala Blanco, and Sebastián Gutierrez.
Greetings, Sacvlc community. I'm Diego Diaz, and I'll be presenting our paper titled Comparison of Different Machine Learning Techniques for PCE Estimation of Millimeter Wave Energy Harvesting Rectifier Devices. The members are Diego Diaz, Esteban Toledo Mercado, Ismael Soto, David Zavala Blanco, and Sebastián Gutierrez. Introduction. In an increasingly connected world, the expansion of 5G networks and IoT technology is a certainty. Coupling that with the recent tendencies towards green energy and electronic device longevity, there is a worldwide need for technologies that comply with all these topics, one of which is radio frequency energy harvesting, which captures the free electromagnetic energy in the air and turns it into usable electric power. The general model of a radio frequency energy harvesting system can be seen in Figure 2A. An antenna captures the electromagnetic AC energy, and the preceding blocks are used to transform it into usable DC energy. This expression can be used to model the process, in which PCE is a very important value, for it allows to predict an output given a certain power input. The main challenge to overcome is that the rectifying devices, usually Schottky diodes, present an extremely nonlinear behavior, greatly increasing complexity in PCE modeling accuracy. Figure 2B shows the actors solely involved in the rectification process, giving an idea of the main variables involved, which are the voltage and frequency of the input signal, the electrical properties of the diode, and the output load. In order to solve this problem, linear models have been proposed, which excel in simplicity but suffer greatly in accuracy. Nonlinear models have also been proposed, and they have great accuracy, but they are extremely complex and hard to replicate. This work will make use of a machine learning approach in order to propose a simple and accurate PCE estimation model. Objectives. We define two objectives. First, the development of a machine learning trained model capable of estimating PCE for rectifier devices with reasonable accuracy. And second, the identification of clear guidelines for further improvements. Methodology. In order to feed the data to the models, an input structure containing all the variables involved must be defined. With that out of the way, a methodology is proposed, shown in Figure 4. First, the data is pre-processed to match the input structure. Then, the data is split in training and validation sets and normalized if necessary. Then the training and testing can begin. And finally, the best model is selected. The machine learning algorithms chosen were support vector regressor, random forest regressor, and neural networks, because they provide a good spectrum between generalization and train fitting. The metrics used to train and validate the models are mean squared error, mean absolute error, and maximum absolute error, because they provide an appropriate way to interpret the model's performance, given they are delivered in the same raw unit as the target and predicted data. The support vector regressor was chosen because it can deal with complex data while providing good generalization. Its main function in principle is to increase data dimensionality in order to find a hyperplane that adjusts to the target value in order to predict it. The training parameters modified were the kernel, which is the tool to increase data dimensionality, C, which regulates overfitting by providing a certain degree of ignoring data that degeneralizes the model, gamma, which signals the degree of spreading away from the data allowed, and epsilon, which defines the tolerance in the error between prediction and reference in order to apply penalization. The random forest regressor was chosen for its ability to fit precisely to data. It's composed by several decision trees whose main function in principle is the choice of thresholds through a node optimizer, that subsequently divide the data in order to achieve an accurate prediction. The training parameters modified were maximum depth, which defined the maximum number of tree decompositions, and number of estimators, which defines the maximum number of trees in the forest. Neural network models provide good fitting and generalization overall, and have highly customizable properties. The main functioning principle is the use of activation functions whose values are approximately and appropriately mixed in order to craft an output data equal to the target data. Its internal configuration parameters are number of layers, number of neurons per layer, and activation function. As for the training parameters, epochs define the amount of times the training iterates through the training set, batch size defines the amount of samples before internal parameter adjustment, the optimizer does the adjustment, and loss function and metric are the metrics to evaluate the model performance. Results and analysis. The used dataset came organized by experiment and diode. So, in order to comply with the input structure, experimental conditions and diode electrical properties had to be added into the set. Figure 8 shows the process through the set column headers. First, the data was split by experiment in order to add the experimental conditions, and then it was split by diode in order to add diode properties. The general procedure for the training of all three algorithms was to find a limited set of values for training parameters in order to achieve a minimum model performance. These values are shown in Table 1. And then trying every possible combination between them. For the SVR, the utilized kernel was the radial basis function, and gamma was defined as a standard value of 1 divided by the input vector dimension. Regarding the neural networks, the activation functions for all layers was ReLU, except for the output layer, in which the activation function was a simple linear activation, meaning there was no major processing in that neuron. Results. The SVR trained models show good accuracy overall, but fall short in the max absolute error metric, meaning that in certain predictions, the error rises up to a 10% PCE. This can be attributed to the need to keep C high, because with low values, the model tended to diverge. This gives the training too much freedom to ignore certain points, causing high magnitude errors, which taken to energy harvesting PCE could mean an entire device ceasing to function. The RGR trained models showed very promising and easy to interpret results. When provided with more depth and redundancy to work with, the model fits better to the training set. The neural networks showed fast learning in the early stages of training, but then that improvement tended to disappear, entering into a stage of intermittent improvement and deterioration. Conclusions. The best model was a trained neural network with a mean absolute error of 0.3 PCE, accounting for the margin of error in every prediction, and a max absolute error of 3.48 PCE, accounting for the worst possible scenario. These metrics show that the model is viable for, at the very least, estimate operational boundaries for the rectifier devices. Neural networks perform better in this nonlinear problem, most likely because they have nonlinear tools to work with, unlike SVR and RFR, which mostly use linear methods to achieve prediction. Regarding the improvements, for the SVR, they can be achieved by looking for a better trade-off between C and epsilon, penalizing error less harshly, but cutting the freedom to ignore data points. For the random forest regressor, improvements are clear. Basically, bigger trees would adjust better to the data, but in order not to overfit, a control technique should be applied, like pruning. Regarding the neural network, even though they provided the best model, training improvement came to a stop after a certain point, meaning model improvements lie in adjusting the internal structure rather than trying different training methods. Thank you for your attention and for the opportunity to submit our research. Goodbye.
Thank you, Diego. We are open for questions. Jose Azoka, please.
Hi, Diego. Look, I am more practical guy. Would it be possible if you could give me some examples of some of the practical application of the model in the practice, what I can use it for?
All right. There's a difference between what this model can do and what it can be applied for. So what the model does, tangibly, you give it a set of parameters, data, and it returns a PCE value, an estimated PCE value. And why do we need that? Why it can be applied to? That is for radio frequency harvesting systems. The reason it's needed or it could be useful is because as of now, conventional current ways of designing a harvesting system is pretty much trial and error. Now, there are models, even though there are models that are pretty accurate. Right now, there's still too many variables involved. So for the current models that we have, the nonlinear models, certain variables have to be fixed, have to be assumed as constant, which means a pretty significant decrease in accuracy. And again, when we're dealing with very low powers, which is the case of energy harvesting, over 3% PCE mistake can lead to an entire device ceasing to function. So the conventional way of designing an energy harvesting system would be first you have to determine select the diode model, and how do you do that? Trial and error. Then the topology of the rectifier, trial and error. Then you have to determine the load, the load on which you're going to deliver the power to, trial and error. So it's a very grueling and long process. And after that, you have to go to the lower layers and determine the rectifier impedance in order to make a matching network, which is, again, a long, grueling process. Now, opposite to that, if we could use this model, well, not this one particularly, because we still need more data and improvements have to be made. But if we take this model and we apply it, this model, what this model would do is it's going to give you a curve, a PCE curve. So with just looking at this PCE curve, you can immediately determine, okay, this diode is helpful for this conditions, this frequency and this input, and with this load. So you immediately eliminate all that heuristic process, and all you have left is to design the topology and the matching circuit. But with those parameters determined, it's almost trivial because it's a mature science, it's a mature aspect. So this model would be very useful for simplifying energy harvesting system design. And I would like to expand on a question that I heard for a previous work that was related to how we can apply this to visible light communication, right? So, at first glance, this could have nothing to do with visible light communication, but that's only because we have a certain, I'm guilty of this as well, a certain very hard bias between information reception and electrical energy generation. And in reality, it's the same thing. And why it's the same thing? Because we have detection and transduction. And that's an element every information reception and energy generation have in common. We detect a certain phenomenon and we transform it into electrical energy. And it's exactly the very same case for light. How do we detect light and how do we transform it into energy? We use a semiconductor. And the process is different, of course, but the variables tend to be the same. If we have a semiconductor, we have nonlinear behavior, we have nonlinear parameters, we have input and output power. So it can also be used to model light detection and every other detection for that matter. I hope I answered, and sorry for taking too long.
Very clear. Thank you very much.
Okay. Fabian, do you have a question?
Yeah, I had a question, but the author already answered the question about the relation between this and VLC. Thank you.
Okay, let's go on. Finally, the last work is from Universidade Federal do Espírito Santo. The title is Remote Control in Smartphone-Based Visible Light Communication. The authors are Igor Campores, Yasmin Pimassoni, Wesley Costa, Marcelo Segato, Jair Adriano Lima Silva, and Elder Rocha.
Hi, my name is Igor Campores. I will present the paper Remote Control in Smartphone-Based Visible Light Communication. This work was produced by researchers of Telecommunication Laboratory, LabTel, located in Federal University of Espírito Santo. Here we have our agenda. We will talk about introduction, methods, results and discussion, conclusion, and future works. The Cisco Annual Internet Report addressed that in 2023, about 70% of the global population will have mobile connectivity. In order to complement RF communication, visible light communication can be seen as a candidate for this growing, increasing the culture of VLC. In this scenario, robotics can be seen as a great way to teach students and enthusiasts interdisciplinary subjects and increase VLC culture. In this case, VLC can be taught using this approach, using do-it-yourself kits, and these kits can be developed at home, which is a great advantage due to the isolation enforced by COVID-19 sanitary crisis. And this approach can stimulate and motivate students because they can develop an applicable VLC system in a short period of time. In this paper, we show the development of a low-cost and remote-controlled toy car using a VLC controller. The evolution of technology has changed many areas of human life, requiring change in educational system to prepare it for new generation like generation Y and Z. Thus, the need to prepare the workforce for this modernized and technological market requires change in the teaching curriculum with inclusion of technology subjects and interdisciplinary projects. Also focusing on Generation Z, change needs to be made in order to meet this generation expectation toward university. And this generation may have some difficulty in developing creative activities, critical thinking, logic, and problem solving. And the use of active learn projects that come out of the traditional lecture class and cannot be solved with a simple Google search, such as problem-based learning, can help with these difficulties. And students are motivated when dealing with something that gives them real feedback, such as flashlight, illuminated displays, rotating motors. Thus, robotic interdisciplinary tools are an excellent way to engage students in different areas. So the designer presented in this paper is a way to engage students in technological areas using concepts of active learning and interdisciplinarity to teach visible light communication in a simple, low-cost, and interactive way. So for that, we use Android smartphone as a controller. And the smartphone is the transmitter, the VLC transmitter. In this case, the hardware for the transmitter is rare in the smartphone, which can reduce the final cost. The camera flashlight was used to transmit VLC signals to control an RC, a remote controlled car. The LED from the camera flashlight was modulated using OOK, where the bit 0 the LED was turned off, for bit 1 the LED was turned on, and the bit period was fixed in 50 milliseconds. And in this case, here we have the frame for our project. In this case, with 80 bits, the first 4 bits it is for a header. In this case, is 1010. It is for synchronization, and the last 4 bits is for the control data that is expressed here in this table. For each direction, there is one control data, and here is a print screen of the application developed. Here we have the hardware of the RC core. In case is the receiver. As a robot is a gray ally of education, we choose a low-cost 4-wheel drive kit to be controlled by the Android. In this case here we use a photodiode, 4 motors, one Arduino, one 8 bridge to control the motors, and one battery and one switch. So here is the strategy to decode the signal. In this case, this strategy allows a dynamic bit period because of the header, and the first step is to recover the header. In this case, the algorithm detect the first rising edge here and get the local time, the next falling edge, the next rising edge, and the next falling edge, and get the local time again. And with this information can estimate the bit period by dividing the time difference by 3, because there are 3 periods here. 1, 2, 3. And afterwards, the core start to sample in the middle of the bit period, like here, 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 and here. So here we have a short video to explain the project. So here we have the effect of the room's light. In this case, the room's light causes some noise, as you can see in the first figure here, with the local light on, and the next figure with the local light off. The local light causes some noise, something about 0.05 volts. And for here we have a picture about the voltage and the distance between the receiver and the transceiver. In the case for the 50 centimeters, the mean voltage is equal to 0.075. It's close to the noise caused by local room. As you can see here in this figure, here we have the signal for distance of 10 centimeters, for 30 centimeters, and for 50 centimeters. As I told, in this case, the signal for B21 is close to the noise from the local light. So this paper presented an application of visible light communication to control a remote-controlled toy car. The project shows satisfactory results in terms of development time and interdisciplinarity between several technology areas. The project can be developed at home, and we believe that it presents itself as a great opportunity to introduce visible light communication system for students and enthusiasts. And the application of this approach with undergraduate students is part of future works aimed to increase VLC culture. We would like to thank Brazilian financial agencies called FAPS, CNPq, and CAPS, and the project Núcleo de Estudos em Tecnologias Emergentes para 5G, Aplicação de tecnologia de comunicação por luz visível em monitorização de recém-nascidos de alto risco. Also, the Brazilian and Germany project optical wireless systems with MIMO architecture in a industrial environment that is financed by CAPS and DFG. Thank you for your attention.
Thank you, Igor. Congratulations. Anyone has a question?
Just a comment. Thank you for the presentation. Have you seen the video clips from, I think it's Walt Disney's research in Zurich? You have?
No.
Okay, I advise you, just for your interest, go and have a look at that. They have a lot of interesting video clips, yes, which might be of interest to you.
Okay, thanks.
Okay, just have a look at it. It's a Walt Disney Research Center in Zurich, Switzerland.
Okay.
Anyone else? Any comment?
Thank you very much, Professor Gazimlai. We'll see the videos. We call this visible light communications, but actually it is a kind of application with optical camera communication, which is one of the hot topics in your labs, as we already know. So maybe in the near future we can change some experience.
Or send the students here for a short-term visit.
Okay. We can. I will send an email to you, and then we can talk a little bit more about.
You can send it for short-term visit to do experimental work. Yes, of course.
Okay. Thank you very much. Thank you very much.
Pleasure.
Okay. Any question?
I have a comment. I would like to congratulate the authors of the manuscript. Initially, when I saw the title, I thought that you guys were talking about remote controls for the TV. So I was really amazed when I saw the presentation. So congrats. And just one question that it wasn't clear to me. What components did you use? Were they basically off-the-shelf electrical components for future work? Because I only saw around 70 centimeters of coverage. How could you increase the coverage area for the communication link?
Okay.
And congrats once again.
Thanks. We use low-cost components, and in this case, it's the LED from the flashlight of the camera is not how to say, is not powered. The LED does not have a large amount of power in this case. And we believe that to increase the distance for the controller with some combination of lens, with some lens in the receiver to get a more signal indicated, because it's a difficult approach to increase the power of this LED, because this hardware is ready and it's not specifically to VLC. In this case, we are reusing the hardware.
Thank you.
Thank you.
Okay, Professor Paulo, we are just in time.
Yes. So I think that we can finish the symposium now. Thank you for everybody.
Professor Fadi.
Yes, if you allow me before we close it, I want to share a few things with the delegates, if it is possible, and then we can officially close it. Can I share it?
Yes.
Okay,
Yes.
let me just.
Sure.
These are a couple of announcements that. Can you see it?
Yes. Yes.
Yes.
So this is the fourth West Asian Symposium on Optical and Millimeter Wave, which will be in next year May in the old city of Tabriz in the west of Iran. And as you can see that we have speakers, including Ismail is included there, and various other speakers from global. And again, this is 2 days event, very similar to this event. They started almost the same time as your event some years ago. So therefore, we encourage people to also support this event. And this event most likely will be online because of the COVID situation. And therefore, you know, it makes it maybe easier for a lot of colleagues to attend. And the deadline for submission is 15th of January. And again, this event is supported by IEEE. All the papers published or presented will be in IEEE Explorer. So please do support it as much as possible, because these events, you know, do rely on our community supporting, and I hope that, you know, we will have contribution from South America or Central America just to show our solidarity with colleagues in Iran. They are just like yourself, young researchers, and they want to promote the discipline in that part of the world. And next one is, can you see this one?
Now we can see it.
What was the deadline of the
15th of January.
Enough, still time.
And this one is, as you can see, that this is the one which is Luis and his team are organizing. This is the 13th IEEE Symposium on Communication System Network and Digital Signal Processing, and it is going to be the 25 years of this event. So we have a big celebration. And this is a big event, and therefore there is a huge colloquium and there an optical wireless communication. And this year we are expecting more than 70 people just on the colloquium alone. So this is normally the biggest gathering of community outside China in optical wireless communication. And we will have a fantastic set of speakers there. They will be announced very soon. And again, here we will have 10 travel grants for people, especially students, to apply. And there will be a one prize for early career researcher to get full scholarship to attend the conference. And that prize will be under the name of Professor Bucqualis, Tony Bucqualis, that we talked about him yesterday. So there's there'll be a number of colloquium, a lot of special sessions. You can see here, these are special sessions organized by researchers like yourselves in topical areas and so on. And again, the deadline for this is somewhere around February, I believe, 16th of February, 2022. And again, we need South America to be actively present in this sort of activity. These are the forums that you're building bridges for your future. So don't just be local, span out as much as possible, and try to build teams for research grants and so on and so on. And you will find these guys in this sort of events. Okay.
Professor, this will be a hybrid or
this will be hybrid. Yes, okay. This will be hybrid. Yes, but we are hoping that by then the Europe will be fine. Okay, and it's going to be in the beautiful UNESCO city of Porto, and so it's a very nice city to be there. Nice wine if you're into wine, nice food, and nice coffee if you're into coffee. Okay, so and finally, let me share this one, which is, again, this is very good for our female colleagues. And I think that my proposal is that the conference that you are organizing in South America must, in my view, promote this discipline within female community. Already you can see that the women in optical wireless communication exists, and these are the various people who have formed it and so on, and they have presence in various medias, you know, and we need people from South America to write to colleagues there or write to me, and I can put it in touch with them as to become a member and get involved with this. And they organize a lot of stuff. And maybe as a future thing for your next event 2022, that you could invite this organization to organize a discussion as part of your conference next year in Brazil, that they have a platform and they can put something together as a community. Okay, so do get involved. And I think we need to basically spread this within our female communities within Central and South America. And I hope that this will also take him with good heart. Okay, that is my. Okay, so you can see that the community is growing pretty fast. And but what we need is that as a community, we need to change as well. We need to shed skin all the time. We need to revise the way we run events. We need to bring in innovation, novel idea. The younger generation are so different to us. And we also need to ensure that the dynamism of the event is fed by new ideas from younger generation. This sort of event is ideal for that because the community is so small. You can always practice new ways of doing things. My view is that this event should basically change the direction a bit. And the direction should be that you should dump the VLC on its entirety. In other words, we shouldn't just be VLC, because the research is moving into infrared, VLC, and Wi-Fi. I think the local committee, especially Ishmael, should take the lead, in my view. Starts basically reflecting what is happening, and therefore into a hybrid event, because this is not going to work on its own. We know that it's not going to work, because 6G is telling us that no single technology will be a dominant one. It will be a hybrid technology. So that's the reason that I guess that the local organizing committee needs to think about it very carefully. Yes, and possibly that will bring new ideas into the community. So therefore, I don't know. You can think about it. We'll have a little discussion later on. And also, my view is that we should also move away to a certain extent by traditional way of presenting papers, 15 minutes after 15 minutes of presentation. And because there is always a predictability of the same pattern repeating itself. And therefore we say, well, is this the best way of utilizing the time of all the delegates and so on, or can we slightly do things differently? Because you can put this presentation online, people can look at it anytime during the last, during the 2 days of event. It is there. I can watch it anytime I want to watch. I think what is missing a lot of event is the discussion, the dialogue, the vision, or the workshop, how people are doing things and so on, where people can learn those skills in a very dynamic environment, where people passing on the experience gained in years and months in the shortest space of time to new generation of researchers. So therefore, they can do better things. Other events can have this format of 15 minutes presentation. That's their view. But for us, it's almost like if we are one big research group scattered all over the world. And we want to bring in always new ideas, new ways of doing things, and so on. And for that, we need to share the skills, knowledge, experience very fast, very effectively. If somebody's, let's say, that's using, like I saw one of presentation of quantum key distribution. This is now becoming a topical in the area of optical wireless. We are moving in as a European community. We need people that work in this area to form a cluster immediately. This cluster is not geographically bounded to anywhere. It's a cluster. It could be anyone from any continent, any countries. So they can bring together all the resources immediately. What are the resources? The human resources. And started talking, okay, guys, this is what we have. This is knowledge we have. This is what we want to, this is where we are going to go. And then we can see that in 5 years' time or 2 years' time, or whatever it's that, quantum key distribution in optical wireless communication suddenly grown with evidence, that the evidence is our publication, research grants, and so on. This sort of forum can plant that seed to allow this clusterization of ideas and concepts to take place. Because we know each other. With one click, we will be connected to one another. The research doing in isolation in a small group is finished. Years ago, it's finished. We are a global researcher. We don't have any countries. We don't have any institution. Your institution is my institution, and vice versa. We are the same. All we want to do is that, do we have a common ground, common values, and common vision and resources in order to implement these things? And we can do it. And that's why I think this subject will grow and become much more interesting, yes? And then we have to allow our younger people to take responsibilities, to take initiative, to run things, to try different things and so on, because they are the future. Without them, there is no optical wireless communication. There is no VLC. We will be talking about history all the time, which is irrelevant for them, yes? So this sort of event can provide that because it's small, because we know everyone. You can request people and they will be willing to help. We are not IEEE, ICC bringing 6,000 people. It's nothing to do with us. That is IEEE. We don't want to mimic that. It's got its own agenda. We have a very specific agenda, and that agenda, we want to build a scientific community where we welcome new ideas, we welcome new members. We also share the resources we have with one another. We don't sort of build wall around our research ideas and so on and so on. No, we don't want to do that. We want to break away all the walls and so on. We want to find resources where young people can travel from one institution to another, spend some time. If they cannot do it, they can do the secondment via online. This is our obligation as a researcher and academic to the younger generation. If we don't do that, we are not academic. We should go and do something else, in my view, yes? So therefore, localized equity should think about this for the next year to bring a bit of different flavor, how this event should be organized and what else it should do, which is, novel. I really enjoyed the 2 days. I attended almost every session except maybe 2 hours I didn't attend because of other meeting. The qualities of presentations are improved. The level of discussion is improved. New ideas moving into areas improved compared to when this was started. So I'm so happy and I'm so grateful for everyone, including the local organizing committee, for putting this very nice program, extremely interesting program. But we are not satisfied with what we have. Of course we are not. We want to do more. And I can see here that there are new ideas injected into the discipline. And I hope that our younger generation have learned something from today and it will inspire them. And hopefully next year, they will come even with much stronger scientific gifts to the events. Yes, they can share it with the rest of the community and so on. So I just wanted to say congratulations to local committee, all our speakers, all our chairs, and so all our audience, which we had a very good audience over the last 2 days. So I'm so pleased. I can sleep well tonight. You know, seriously, I can sleep because it was great. It was lovely, as English say. This is really a lovely event, you know, and that's it. So I'm as a person, as a scientist, I'm very happy, and thank you very much.
Okay, thank you.
Thank you very much, Professor.
Barry, please, don't forget to tell us the statistic that we did and the next event.
I mean, I think I had something from Ismail. Yes.
Yes. Yes.
So we have Ismail has been doing some homework, which is great. Yes. So
Diego did that. Diego did that.
Yeah, we have, you know, you can see that day one we had 40 people on Zoom, we had 18 people on YouTube and 166 view, which was great, you know. And the same day two, same pattern is repeating. Okay, so you can see that on average we are working about 50 people attending via YouTube or Zoom. I think that's a fantastic thing for the event. You should have your head very, very high and should be proud of it. And I hope that I'm sure that next time will be even better than that. And I believe that the next event is moving into Florianopolis, the city of Florianopolis in Brazil. And I hope that by then this bloody devastating COVID is gone, so we can start traveling, we can start hugging each other, holding each other, and showing things that we have built, possibly going for a coffee and drinks and so on. Yes, this online thing is destroying everyone, you know, because we are all tired of this online thing. We are all tired of COVID, and so. And then the number of papers was, if you look at that, this is a fantastic rate. 52% of the papers were rejected. Although this conference gave the opportunity to authors to review their papers and revise it. Normally in a conference, you don't get a chance to revise your paper. But these sort of conferences, they act like a journal. They give you a chance to review you and revise your paper. You see, this is the benefit of it. We are feeding back something to the authors.
Yes.
And he said that learn from the reviewers and revise it and so on. We don't want to be IEEE have a very high rejection rate. No, that's not the aim of what we want to do. We want to assist. If someone is struggling with the concept, maybe a bit of hint, a bit of help will put them in the right path. And that is the essence of this sort of events. The sense of community, the sense of looking after one another scientifically, rather than dismissing it. Because other big conferences, they don't have the resources to give reviewers comments and so on. They just dismiss it. And then that becomes the norm and standard, in my view. I don't agree with that, but that's it. It's nothing to do with me. Okay, so this is a fantastic thing, yes? So, and I hope that, you know, you guys also notice that the qualities and so on, and I look forward for the next one. So we need to start the process very quickly in the next couple of months. Keynote speaker, invite the speaker, workshop, training things, and so on and so on. So we have a lot of 12 months is very short, and it will be there with us very, very quickly. That's it from my side.
Thank you very much.
Okay.
Professor Radu, are you there?
Well,
yes, please.
I enjoyed the conference, and I think it's well done. It's a very successful conference. So I look forward to see what things develop after this.
Thank you very much. Thank you. Anyone else want to give a shout?
Yes, from the audience, if there is any
Yes.
things that they want to share, by all means, just put your camera on and microphone on, but keep it short.
For the last picture.
Yes, yes. Have your camera on.
Yes, yes, I will.
Hi, Mircea.
Yeah, Diego, are you there? Yes.
Yeah, I'm here. I can take the picture for you.
Cesar.
Okay, so somebody else wants to turn on your camera?
Yeah, don't be shy. Put your camera on and then.
Yes.
Sergio, put your camera. You did
Hi, Brazil.
Yes, you did very well, Sergio. You put a lot of effort today. Yes, and that's important, as far as say. That's important. Yes, of course. Next year will be better, yes?
Yes, I hope that COVID is gone.
Yes, we are a community.
Yeah.
Yes.
So
yes,
say cheese.
Cheers.
Cheers.
Cheese or cheers?
Cheers. You can have both of them, cheese or cheers.
It's both. Okay, again. Say cheese again.
So, thank you very much for the audience.
Ishmael, are these papers? I know that because the papers will be in IEEE Explore, yes?
Yes.
Okay. Because we cannot put them on the website because it is copyright until they're published in the IEEE, so we cannot distribute it unless.
Well, yes, we put the video. Yes, and we have all the copyright. Yes, yes, maybe.
You can put them, those will be available on the website.
Yes, Fabian, please, can you give us some details?
Yeah, today I received the email from the IEEE, so tomorrow I will be compiling all the copyrights if everything goes well. Next week, already send the papers to IEEE to be published.
Yes, because we learn how to manage IDAS.
Yes, that is, I mean, this is a thing that, we could learn, we could share this how to use IDAS. I mean, we have a colleague, Joachim from Spain. He's very good with IDAS, you see.
Yes.
He's an asset to have because he navigates through it so quickly.
Yes, Fabian did very well this time. Yes.
Yeah, good. And this is what we could share this sort of thing. We don't need to reinvent the wheels.
Yes, and we have an option that the copyright are already, and if he presses a button, he will send the paper next Monday. Yes, because we this time we did that. Yes, and we had to pay a bit, but means you see fast dissemination of the.
Yes. It was paying that. It was, and also
at the beginning, yes.
And also EDAS it belongs to our community. We need to support it. Without our contribution, they cannot survive.
Exactly.
So we may, although we wish everything to be free, but someone has got to pay in order to keep them going, So this is. Any other comments from the delegates or audience or?
Just to say thank you to all of you. We are happy as well.
Good.
I think we did even better this time.
Absolutely.
We are proud.
We're proud.
Yes. You should be.
Thank you very much.
These words are invented for this sort of occasion, that we are proud of what we have done. Of course.
Yes.
In my case, I remember the first event, I think 2 or 3 years ago.
3 years ago.
I'm sure, but compared to the first event, now there is more people. The quality of the papers has increased. I have seen papers from different parts of South America that I had no idea 3-4 years ago that we're working on the topic. So
you mentioned that. You mentioned South America. Let me I need to open something and I want to show this to you. If you allow me, please, because I think I have faced deficiency of information on South America. And let me just go to my global. So we have okay, I can share this with you, and then you can tell me if I am missing any part in South America. Okay, let me just share so you can see it. This is something that I produced 2 years ago. Can you see it?
Yes.
Yes.
And this is a global research map in visible light communication, which annually we update it and publish it in LinkedIn, ResearchGate, and various other social media. So I need you guys to tell me that whether I am, if in America, we start from the Canada, USA, Mexico. I think we have a couple of Central America, Ecuador, Brazil, Chile, and so on. I don't know whether I am missing any other countries who are active in this area.
Peru.
Peru?
Yeah, Peru. They have a project in health and visible light communication.
Fantastic. I can add it now. Peru. Anyone else?
Groenland, no.
I don't know if this could work officially this way, but one of the researchers in our group is from Bolivia, actually, but he's in Chile working, but he's from Bolivia. But he's actually
No,
working
I want institution in the country.
Oh, okay.
Yes.
Okay, no,
In other
so
words, they have
don't count.
published and the name appears in our in the global domain that somebody said, oh, there is a university research group or company.
Oh no.
Jair Silva is saying that in Africa they are one country.
Which country is it, Jair?
It's in the chat.
Cape Verde. Cape
In
Verde.
where?
In the chat.
It's a small island.
Yes, 10 small islands.
Cabo Verde.
Cape Verde.
Yes.
Where is it?
Cape Verde.
It's in Africa.
Yeah, I know, but where about?
It's close to Senegal, Atlantic Ocean.
Very small island.
10 small islands in the ocean, in the north.
Oh, it doesn't. I don't think it's even here, is it?
Yeah.
It is so small that sometimes it doesn't appear in the maps.
You can see Senegal there.
Senegal is here. Senegal is here.
Yes,
so it's those islands.
Front of Senegal in the ocean Atlantic.
So it will be somewhere here.
Yes, exactly.
Okay. Any other places that we are missing globally? I think we are okay. Yes.
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 Good. So I can save this and then keep it for next year.
Sorry, I bought it. What is that?
Right. I guess that is time to say goodbye.
Bye, my friend.
And see
We
you
don't want
soon.
to say goodbye, but we have to.
We have to. Yes. I need to go and have my lunch.
To stay here.
My coffee.
Talking for a while.
You guys need to go and have your lunch as well or dinner,
Yes.
and then have a lovely evening and weekend.
Life must go on.
Yeah. Looking
Okay.
forward for the next event.
Yes.
Okay. Okay, see you soon. Goodbye.
Goodbye, guys.
Bye. Thank you.
Thank you.
Bye-bye.
Yeah.
Take care, guys.
Thank you, everyone.
Felicitaciones, Ismael.
Take care, guys.
Thank you, Farid. Thank you.
Yeah.
Thank you.
Bye bye, Aaron.
And delegates. Yes. Thank you.
Thank you, everybody.
See you. Bye bye.
Bye.